Hello and welcome to the introduction video of Data Science and Machine Learning course. In this video, you will learn about all the steps that are involved in the complete data science project lifecycle, from data acquisition to data pre-processing, data cleaning, modeling, and checking the accuracy and validation of the model. So, what will you learn in the course? After completing this course, you will have a better understanding of all aspects of data science and machine learning. This course covers all steps involved in the entire data science project lifecycle, from data acquisition, data cleaning, data pre-processing, building machine learning model, testing the accuracy and predictions made by that model. Now, this course will provide you with crisp and information-rich content that will help to focus on the most relevant and crucial topics in data science. So, how to access the study material for this course? The resources section contains all presentations having the theory concepts, the datasets used in practical section, and the Jupyter notebooks. So, all videos and resources are downloadable. So, you can download them and save them on your local machine, and you can maybe refer them later for practice purpose. Now, how to approach this course? So, you can follow all the videos in the order of the course curriculum arranged. The videos are recorded in a very specific format for the most impactful learning. All the theory concepts will be explained first, and then we'll see the practical implementation of the same concept. So the order of video is such that, let's say we are studying a particular machine learning algorithm, for example, a random forest algorithm. So the video will first cover the basic theory concept required to understand that random forest algorithm. Then the second part of the video will have the practical implementation of the random forest algorithm with any dataset in the Jupyter notebook, and all the resources used, like the dataset on which will perform the algorithm, the Jupyter notebook itself, and some course presentation that contains the theory will be available in the resources section. So Jupyter notebooks and datasets used for practical demonstration can be found in the Jupyter section, in the resources section. Now, useful tips to get the best out of this course. Once you have watched the video tutorial for a particular concept, then try to implement the practical example by yourself using a different dataset. Now, by doing this, you will be able to develop better understanding about that concept. Try to make some kind of mini projects by using the different datasets, and you can use the same concept and maybe try to tweak the algorithms that you have learned in the video. So if you follow this approach, you will definitely have a strong understanding of all the concepts that are discussed in the course. I hope you're clear with the basic introduction about the course. Now let's move to the next video, which will give you a basic overview about the course curriculum. Thank you. Hello and welcome to the course overview video. In this video, you will get a very good understanding of all the topics that are covered in the course and also the flow that we are going to take throughout the course. So firstly, the course will start with NumPy. So the course starts with covering some of the basic and most important concepts of NumPy, which will create a strong foundation for your data science journey. Now, NumPy is a Python library that is extensively used in data science to perform quick mathematical operations. So having a very strong understanding of NumPy will definitely help you in understanding some of the most advanced concepts in data science. Now after NumPy, we have a separate section for pandas, because all the CSV data that you are going to use in your data science project will be stored in a pandas data frame. So the pandas data frame can be considered as the heart of the any data science project. Now, other like all the data cleaning and pre-processing tasks before the modeling will also be done mostly in pandas. So pandas is one of the most crucial and important thing that you can learn to improve your data science skills. Now, after completing NumPy and pandas, we'll move to the data visualization. Now for data visualization, we have covered two Python libraries, that is matplotlib and seaborn. So using matplotlib and seaborn, you will learn to make impactful visualizations which will help you to derive meaningful conclusions from your data, and that is a key aspect of any data analysis project. So NumPy, pandas, data visualization. Moving on, the next section that we have is for the data preparation and data pre-processing. So this is one of the most important and most neglected step in the entire data science project pipeline, because once you have acquired the data, then before directly jumping onto the modeling, you should actually prepare the data properly to get the best results from your model. So this section covers topics like dealing with missing values, feature encoding, etc. etc. So before moving on to the modeling part, you have to follow the all pre-processing and data preparation steps in order to achieve the best results from your model. Now, finally, after completing the NumPy, Pandas, visualization and data preprocessing, we'll start with core machine learning. Now, in this section, you will learn about types of machine learning like supervised, unsupervised, and we'll also cover different machine learning algorithms like SVM, KNN, logistic regression, random forest decision trees, linear regression, and clustering algorithms like uh, k-means, etc. etc. Now, this section also contains a video session on hyperparameter optimization using Grid Search CV. So, by using the Grid Search CV, you will be able to identify the best hyperparameters that you should use with the machine learning algorithm in order to achieve the best results. Now, videos will cover the basic theory concept for that particular machine learning algorithm. Plus, they will have the practical implementation of each and every machine learning algorithm in a separate Jupyter notebook. Again, you can find the data on which the algorithms are used and the notebook itself in the resources section. You can access them and practice using it later. Now, after that, we'll learn to build a complete machine learning pipeline plus some of the projects. Now, in the last two sections, you will learn to build the entire machine learning pipeline and will also do two projects. So, the entire machine learning pipeline will be like we start with the data acquisition, we load it into a pandas data frame, then we move to some analysis and visualization part to derive some conclusions from the data. Then we move to the feature encoding and maybe data cleaning if it is required. Once we have prepared the data properly, then we move to the modeling stage, and finally we check the accuracy, etc. etc. of the machine learning model. So this is the entire machine learning pipeline. So a pipeline basically is that where the output of first stage goes as the input to the next stage. So we'll learn to build the entire machine learning pipeline and we'll also do some projects. So I have included two different projects into the course. The first project is based on the classification problem in machine learning, and the use cases will predict diabetes using a classification algorithm. And the second project is about a regression problem, and the use case is that we'll try to predict the cost of the insurance premium using regression in machine learning. So I hope you are clear with the entire course overview of the data science and machine learning course. Now let's move to the next video. Thank you for watching. Hello and welcome to the introduction video on NumPy. In this video, we'll learn about the basic introduction and how do you set up or install NumPy on your machine. So, first let us develop the basic understanding about NumPy. What is NumPy, why do we use it, and how it will be beneficial in our data science and ML journey. So NumPy is the building block of all the other tools and technologies that we are going to see later in this course. So as in the basic section, first we'll work on NumPy, Pandas, and then eventually we will move on to the advanced data science and ML stuff. So here the first thing that we're going to discuss is what is NumPy. So NumPy is basically a Python library that is used for working with arrays. And the good thing is that NumPy also has a lot of ready-made inbuilt mathematical functions in the domain of linear algebra, Fourier transform matrices, and etc. etc. So if you have already studied about the basic high school math or some college level mathematics, then you would be aware about all these mathematical terms. If not, don't worry, we are not going to go in very depth of all these mathematical terms. We'll just cover the basics that are required for our understanding of the ML algorithms. So NumPy is very helpful in that domain. Now it was created in 2005 by this gentleman called Travis Oliphant, and it is an open source project, so you can use it freely. And the full form of NumPy, basically NumPy stands for numerical Python. So now why should we use NumPy? So as I think as a prerequisite, you already know the basic Python for this course. So in Python we have studied lists and that serve the purpose of arrays, but lists in Python are very slow for the process. So NumPy aims to provide an array object that is up to 50 times faster than the traditional Python lists. So the main important key feature of NumPy is that the NumPy arrays that we work upon are 50 times faster compared to the traditional Python lists. Now the array object in NumPy is called ND array. So this is the key object or key data structure that is the NumPy array that we are going to use, and it provides a lot of supporting functions that make working with NumPy array very easy. And arrays are very frequently used in data science where speed and resources are very important. So for example, if you're working with a huge data set in a data science or ML project, then using NumPy arrays compared to the traditional Python lists will save you a lot of time and resources, and it actually makes your working very efficient. So this is where we use NumPy. I hope you are getting the point. Now let us understand about the installation. So to install NumPy on your system, just use the simple command pip install NumPy. So you've already seen the installation and working of Jupyter Notebooks, and after this presentation I'll also give you a practical demonstration on how to install NumPy on your device. So you just have to write this simple pip install NumPy command. After completing this presentation we'll see that. Okay, now let us understand the sample code and then we'll try to implement in the practical session. So here we have imported the NumPy. So import NumPy as NP. This is the alias that NP is the standard alias that everyone uses while working with NumPy. So import NumPy as NP. Then we are making this array variable called ARR and then np.array. So array is a function in NumPy that is used to make one array. So inside this array function we are giving a normal Python list. As you can see, this is a simple Python list that has 5 elements 1 2 3 4 5. When this list is passed inside this np.array function, it will automatically create a NumPy array, and the name of this array NumPy array will be ARR. And now when we'll print ARR, we'll get the desired output as the NumPy array. We'll study later about the dimensions and types of different NumPy arrays and all the operations, searching, sorting, iterating through the NumPy arrays later in this NumPy section only. But for this video, this is just a sample code that I wanted to show you. Now let us move to the practical session and understand the working of all this in the Jupyter Notebooks. Thank you. Okay, so let us get started with the practical session on the NumPy introduction. First of all, let us see the basic installation on how will you set up NumPy on your device. So as already discussed during the presentation, you have to use this command called pip install NumPy. So in the first cell of your Jupyter Notebook, just type pip install NumPy. You can also use this exclamation mark. As you can see on my system, NumPy is already installed, so it gives requirement already satisfied. But if you do not have NumPy installed on your system, then by using this command you can install NumPy. So after this installation part, let us run a sample NumPy code to develop your understanding. So we can just simply write import NumPy as NP, and then we'll make one array. So ARR is equal to np.array. So this is the NumPy function for building one array, and we can give one Python list as the input to this function, and it will make a NumPy array out of it. So we'll just write a simple Python list, let's say 1 2 and 3, and then if we try to print this ARR, and let us see what do we get as the output. So the cell is running, and as you can see we have now a NumPy array. So we can also check the type of this array, and as you can see the type is np numpy.nd array. So initially this was a Python list. Now we gave this list as an input to this np.array function, and this is now a NumPy array as you can see in the type. So I'll just quickly repeat what we have done in this code. On the first line, this is a very common practice for all the programs that we're going to use later in this NumPy section. So import NumPy as NP to import the NumPy library, and then we have made this array variable using this np.array function. Inside this function you can give a Python list to make us array. Now we'll discuss more on the dimensions of the array and other stuff in the next few videos, but as of now you can just understand by using this function we can create a NumPy array. Then we are printing this array, and then to just confirm we are checking the type of this array, that is numpy.nd ND array. So I hope you are clear with the basic installation and the basic sample code of the NumPy. Now we'll move to some more advanced topics on NumPy in the next few videos. Thank you. Hello and welcome to the next video in the NumPy section of the data science and machine learning course. In this video, we'll learn about creating different types of arrays and try to develop our understanding about NumPy arrays in much more detail. So first of all, let us start the code with the revision of the basic program that we discussed in the previous video. As this code says, we have to just create a simple array in NumPy. So how do we do that? We'll import NumPy as np, then we will make one ARR variable and we'll use this function called np.array, and inside this function we'll pass one Python list, and then we have a ready-made NumPy array, and as you can check by printing the values of the array or also by checking the type of the variable in Python. So NumPy is used to work with arrays, and the array object inside NumPy is called the ND array that we have already discussed. Now we can create a NumPy ND array by using this array function. That is also done. So up till this part we are very clear. Now let us move to the next topic, that is called dimensions in NumPy array. So this is very important concept and try to focus on this very carefully. So the next few sections of the course will be very easy for you if you develop this concept right now. So let us understand. A dimension in array is one level of array depth, that is we can also call the nested arrays. Now in NumPy we have different dimensional arrays. So first of all, we'll see the 0D arrays, or we can also call them scalars in NumPy. So scalars or 0D arrays are the elements of the array itself. So each value in a 0D array is a 0D array or a scalar. Now an array that has 0D arrays as its elements is called unidimensional or a one-dimensional array. So these are the most common and basic arrays. And array that has 1D arrays as its elements is called a 2D array. Now the 2D arrays are often represented as matrix or second order tensors. Now we can increase this one step ahead, and we can also say that an array that has 2D arrays or matrices as its elements, and these types of arrays are called 3D arrays, and these are also known as third order tensors. So let us go back and understand over here. So inside this NumPy array, each unique value that we have 1, 2, 3, 4, 5, these are called zero dimensional arrays or a scalar. So this itself is a scalar quantity. Now this array itself, if you check the dimension of the entire array, that is 1, 2, 3, 4, 5, this will be given as a single dimensional NumPy array. So I hope this is clear. Now to create a 0D array with one value. So a 0D array or a scalar is just one single value in NumPy. So we can call this np.array and just pass this one single value, and this will create one simple 0D array in NumPy. So now let's take one more example and see how do we create a 1D array. So this what we were doing up till now was we were creating a single 1D array. Now this 1D array contains 5 different values, and these 5 different values itself are a zero dimensional array or a scalar quantity as we say in NumPy. So this will create a 1D array, and let us also take one example for 2D array. Now this array, as you can see, has 2 different dimensions. So create a 2D array containing 2 arrays with values this and this. The entire code will remain the same. Only the thing that you pass inside the np.array function will change. So as you can see, this is the first dimension and this is the second dimension. So 1, 2, 3 and 4, 5, 6. So this itself is a 1D array and this itself is a 2D array. If we come back to this slide, as it says, an array that has 1D arrays as its element is called a 2D array. Just focus on this line. An array that has 1D arrays as its elements is called a 2D array. So now look at this array. This array is a 2D array and it has 1D array, this 1D and this 1D array as its element. So as its element. So this is a 2D NumPy array. Now we can also increase this to one step ahead and we can create one 3D array with 2 different 2-dimensional arrays like this. We'll see all these examples in our practical section also. I'll teach you how to make a single scalar quantity or a 1D array, 2D array, 3D array in the practical section just after completing this presentation. Now, just for the confirmation, like how to check the number of dimensions of the array. So numpy arrays provides the ndim attribute that returns an integer and tells us how many dimensions in the arrays that we have. So what we can do here, as you can see on this code, we have created 4 different arrays. This is a 0D array, this is a 1D array, this is a 2D array, and this is a 3D array. So what we can do, we can just call this dot ndim attribute. So A is a 1D 0D array. We can just simply write a dot ndim. So it will return the dimensions of first array. This will return the dimensions of B, this C, and this D. So this is how we check the dimensions of the numpy array. So I hope you are clear with all the concepts discussed in the presentation. Now we'll move to the practical part and try to implement all this in our Jupyter notebooks. So let us start with the practical implementation of creating arrays of different dimensions in NumPy. So first of all, let us look at a 0D array. Let me give a markdown 0D array. Now we'll import numpy as np, and then what we can do, we'll make this variable called a, and we can write np dot array, and as this is a 0D array, so it will contain only one single element, let's say 55. Now we have one array, and if we try to print a, we are getting array 55. So this means that it is a single dimension array. We can also check the type of a, and we also saw this attribute called ndim, a dot ndim. So this returns 0. That means this is a 0 dimensional array. This ndim attribute is used to check the dimension of the array. Let's create one more array b, and this time we can use np dot array, and we'll write 1 2 3 4. So this will be a 1D array, because as already discussed in the theory part, that a 1D array is a collection of different 0 dimension arrays, and or the scalar values that we call in NumPy. So to create a 1D array, we can just simply write one Python list. This can also be a one point of view. We can also write one simple Python list inside the np.array function. So this will create one single 1D array in NumPy. So let us run this cell, and if I check b dot ndim, this time as you can see, we are getting 1 in the output. Now let us try to create a 2D array. So and let me change it to markdown, and in the next cell what we can do, I'll write c and np dot array, and this time to create a 2D array, we can just pass 2 different Python lists. So what we can do, we'll just write 1 2 and 3, and again we'll pass one more list. So we can write 7 8 and 9. So this will create a 2D array. Okay, we forgot one thing, we just have to pass the entire thing into one more square brackets. So now if we try to run this, this will create a 2D array. So to create a 2D array, inside a square brackets, pass 2 different Python lists. So this is a simple 2D array in NumPy. Now to check, okay, first of all let us try to print the array. As you can see, this is printing in the form of a matrix that we already discussed in the presentation. Now we can also check the dimensions of the C array, and as you can see, it is 2. So this is a 2D array. Now we'll create one 3D array. So to create a 3D array, we'll make one new variable d, and we can write np dot array, and inside this array function, first of all we'll open one single square brackets 1 2 3, and then we have one more square brackets 4 5 6. Then again we'll close this. A 3D array will be a collection of 2 different 2D arrays, right? And then again we'll copy the entire thing and paste it over here, and this entire thing will be enclosed in one square brackets as we did in the 2D array. So a 3D array will be a collection of two different two-dimensional arrays. This concept we already discussed. So in 2D array, what you can see, it is a collection of two different one-dimensional arrays. So similarly, if we increase the hierarchy, a 3D array will be a collection of two different 2D arrays. If I run this cell and if I try to print D, so as you can see, we are getting two different 2D arrays, and this entire thing itself a three-dimensional array. We can also check this by doing the endim attribute. So this is returning the dimensions 3. So this is how you work with different dimension of arrays in NumPy. This we created a 0-dimensional array, that is just a single value. Then to create one-dimensional array, just pass the single Python list inside the np.array function. To create a 2D array, the 2D array will be a collection of two different one-dimensional NumPy arrays. The 3D array will be a collection of different two-dimensional arrays. So this is how you work with arrays of different dimensions in NumPy. I hope you are clear with this concept. Now let's move to the next video. Thank you. Hello and welcome to the next video in the NumPy section. In this video, we'll understand about the shape of a NumPy array and how can we reshape a NumPy array. So let's get started. First of all, let us understand about shape of an array. The shape of an array is the number of elements that are present in each dimension. Let us understand that with the example of a code given over here. So import numpy as np, we are making one array. This is a 2D array. So 1, 2, 3, 4 and 5, 6, 7, 8. Now if you see, this is a two-dimensional array, and if you run this code, you will get the answer as 2, 4 because it has two dimensions and 4 elements are present in each dimension. So this is the shape for this particular array. This will be more clear to you when we move to the practical section and understand this with the help of live code demonstration. But as of now, just understand this, the number of elements present in each dimension of that array, that is called the shape of the NumPy array. Now let us see about reshaping of arrays in NumPy. This concept is very important and you will find yourself working a lot using this concept when we move to the more sort of project or practical case study data analysis part. So reshaping means changing the shape of an array. Now the shape of an array is the number of elements present in each dimension. By reshaping, we can add or remove dimensions or change the number of elements in each dimension. Let me read this statement one more time. By reshaping, we can add or remove or change number of elements in each dimension. Now let us see this. How do we reshape 1D to 2D? So here we have an example. Convert the following 1D array with 12 elements into a 2D array. Now what this will do? So we'll have this 1D array ARR and it has 12 elements 1 to 12. To reshape any array in NumPy, we have this function called reshape. Now this array has 12 elements and we have to transform it into 2D. So we have to think of such numbers, the multiplication of any two numbers that results into 12. So we can either take 4, 3 or 3, 4. So by using this function arr.reshape, and we are storing this new 2D array that we have reshaped from the original 1D array into this variable called new arr. So let me explain this code one more time. Here we are already having one array called arr and it is a 1D array containing 12 elements. Now the task given to us is that we have to reshape this array into a 2D array. So the outermost dimension will have 4 arrays with 3 elements. So we'll reshape this arr.reshape, arr this array, and we are calling dot reshape and we are giving 4, 3, and this newly reshaped 2D array from this original 1D array we are storing into this new arr. So this is how reshaping of array works in NumPy. Now the question comes, can we reshape into any shape? So yes, as long as the elements required for reshaping are equal in both the shapes. So we can reshape an 8 elements 1D array into 4 elements in 2 rows in 2D array. But we cannot reshape it into 3 elements and 3 rows of a 2D array, as that would require 3 into 3, 9 elements, as I already told. In this example, we have one 1D array containing 12 elements, and we can reshape it into a 2D array because 4 3s are 12. That will be the almost all elements will be comfortably fixed into this 2D array of 4, 3. But this we cannot do. We can reshape an 8 elements 1D array into 4 elements in 2 rows in 2D array. We can do that, but we cannot reshape it into a 3 elements 3 rows 2D array because this requires 9 elements and we only have 8 elements. So this is not possible. We'll take few more examples of shape and reshape of NumPy arrays when we move to the more practical section. But as of now, you just remember this very important point. Now again, one more important topic, flattening the arrays. This will be again used very much when we work with large data sets, and this concept is required when you give a certain dimensional input to a machine learning model. So that is very much important. Now flattening array means converting a multidimensional array into a 1D array. This is a simple statement or a simple one-line definition for flattening any array. So flattening array means converting a multi-dimensional array into a 1D array. So to do this, we can simply use this reshape -1. So have a look on this code example over here. We are having one ARR array, np.array. This is a 2-dimensional array. As you can see, this is the first and this is the second dimension. Now we want to reshape this into a 1D array. So simply we have to call arr.reshape, and into .reshape we have to give the argument -1. So this is this can work on array of any dimensions. Here I have shown you the example of a 2D array, but this can also be done with 2D, 3D, 4D and higher dimensional arrays. So this is a very important concept of flattening the arrays. I hope you are clear with all the concepts that we covered in this presentation. Now let's move to the practical section. Thank you. So let us start with the practical section of shape and reshape concepts for a NumPy array. So I'll show you few examples in this practical section, but let me first import my NumPy as np. Now after that, I'll make one array called a and np.array, and I'll simply make a 1D array 1 2 3 4 5. And what I can do to check the shape of this array, I can simply write a dot shape. So this is a 1D array and it only has one dimension, so it will only show 5. So this is the shape for this array. Let me show you the same shape function on a 2D array. So let me make a new array np dot array, and this time I will make a 2D array. So 1 2 3 4, and again the second dimension 5 6 7 and 8. So this is a new 2D array, and I'll write b dot shape. So this time, as you can see, I am getting 2, 4 as the answer. So as this is a 2-dimensional array, and if you remember the formal definition for the shape of a NumPy array, it tells the number of elements present in each dimension. So this is a 2D array and the number of elements present are 4. Now moving on to the next thing, we are going to see about reshaping the array. So what I'll do, I'll create a, okay, let me copy this and let me change the name to C, and let me add few more elements 6 7 8 and 9 10 11 and 12. So this is a new array C. It is a 1D array and it contains 12 elements. Now I can reshape this array into a 2D array, and that has 12 elements. So a 4 cross 3 2D array. How can we do that? We can do that by using the reshape function in NumPy. So what I'll do, I'll use C dot reshape and I'll write 4, 3. Now this new reshaped array will be stored over here. So I can write new underscore arr is equal to C dot reshape. So I'm reshaping the original array and I'm storing it into new underscore arr. And I can again see how new underscore arr looks. So new underscore arr looks something like this. To just confirm the concept, I can first check the shape of C. So C dot shape. So it is a single 1D array having 12 elements, and if I can write new dot a new underscore arr, and if I want to check the shape, so it is 4 cross 3. So this is how you reshape a NumPy array. Let's try one more example. So if I want to change it into a 3D array, so what I'll do, I can write new underscore arr2 will be equal to c dot reshape 2 comma 3 comma 2. So this again makes 12, and to confirm that I can see new underscore arr of 2. So this is what we are getting. We can also check the shape for this new underscore arr 2, and this is 2 comma 3 comma 2. So this was about the concept of reshape. Now let's take one example on flattening of arrays. So basically, if you call reshape and pass the argument as -1, so it will reshape any array of any dimension into a 1D array. Let's try this. I'll make a new 2D array and 2D underscore array, and what I'll do, I'll give some elements, and I want to flatten this array. So I'll write 1 2 3, and in the next bracket I'll write 4 5 6. So this is a new 2D array, and flatten array will contain 2D array dot reshape, and I'll give -1 over here. So this is our new flattened 1D array. What I'll do, to check this, I can see what we have in the flatten array. So this is a single array of one dimension containing all 6 elements. I can also check the shape of this array. I'll paste it over here, and I'll write dot shape. As you can see, it is a single 1D array containing 6 elements. So I hope you are clear with the concept of shape of a NumPy array. How do we reshape arrays in NumPy, and what is flattening of NumPy arrays? Thank you. Let's move to the next video. Hello and welcome to the next video in the section of NumPy. So in this video we will learn about the array indexing in NumPy. So how do you access array elements from a NumPy array? So array indexing is same as the accessing an array element, and now you can access an array element by referring to its index number. So each and every element inside a NumPy array has a certain index number, and if you want to access that particular element, you can access it by referring to its index number. So the indexes in NumPy array, they start with 0, meaning the first element of the array will have the index 0 and the second will have index 1. So as you already know, if you are already aware about the indexing in Python lists, and similarly the index of the first element in NumPy array also starts with 0. So fairly simple. Now we'll just have a look at a simple sample code. Now what you can do, if you want to get the first element from this one dimensional array, that is 1 2 3 4. Now this indexing may and NumPy array indexing may also change based on the dimensions of the array, that will cover later. But as of now, for this code, we are just focusing on a simple one dimensional array, a single NumPy array that contains 4 elements 1 2 3 4, and the dimension for this array is 1. So the index for the first element will be 0, this will be 1, this will be 2, and this will be 3. So as this array contains 4 elements, the index will start from 0 1 2 and 3. Now if you want to access the first element, you can simply write arr of 0. This is very similar to the accessing or indexing in Python lists. So if you are aware about that concept, this will be fairly easy for you. The other part of the code is simple, that we discussed in the last section. So import numpy as np, we made a simple 1D array, and after making this 1D array, we are trying to access the first element from this array. So the first element is 1. If you write this code, and in the output you will get 1 in the first element. Now what we can do, we'll just try to take a complex problem. What we are saying over here, we want to access the third and fourth element of this array, and we want to also add them. So we can perform this in one single step. First we'll make this array 1 2 3 4. Now arr of 2 will be 3 and ARR of 3 will be this element 4. So if we try to add them directly over here, we'll get the answer. We'll also see this demo in the practical section. So ARR of 2, by writing this, will be able to access 0, 1 and 2, this element. So 3 will be placed over here, and 4 by ARR of 3, that is the index position of 4 is 3 for this array, and 4 will be placed here and we can directly add them up. So this is another use of array indexing. Now let's move to the 2D arrays. How do you access elements from a 2D array? So we can see that to access elements from 2D arrays, we can use a comma separated integers representing the dimension and the index of the array. So you can think of a 2D array like a table with rows and columns, where the rows represent the dimension of the array and the index represents the column of the array. Let me explain this with the help of an example. So as you can see, here we have a 2D array 1, 2, 3, 4, 5 and 6, 7, 8 and 10. This is a 2D array. As already discussed, this 2D array is a collection of two 1D numpy arrays. This is a this list 1, 2, 3, 4, 5 is a single numpy array, and this another list is another numpy array. So what we can do to access elements from this 2D array? So first let us try to access second element from the first row. So second element, the index of the second element will be 1 because the index starts from 0, and the index of the first row will be 0, right? So index of the first row, that is 0, and then to access the second element we can write 1. So 0 comma 1, by writing this ARR 0 comma 1 into the square brackets, we'll get the second element from the first row. This will be more clear to you when we move to the practical section. So without any delay, let's move to the practical part and try to implement all this in a Jupyter notebook. So let us start with the practical implementation of array indexing. First of all, as usual, I'll import numpy. So import numpy as np. Now I'll create one array. I'll create one 1D array and let's name it A. So np dot array, and I want to create a 1D array, so let's give 4, 3, 4, 5, 6. So this is an array A and it has 4 elements 3, 4, 5, 6, and dimension for this array is 1. So now let us have a look on indexing. So if I write A of 0, then I'm getting 3, because as already discussed, the index in the numpy array starts with 0. So when you are telling numpy to access the first element, that means you're giving the index position for that particular element. So the index position for the first element, that is 3, will be 0. Now if I want to access this element number 3, the value for that element is 5. So how can we do that? So this will be index 0, this is index 1, and this will be index 2. So if I write A of 2, then I'll get 5. We can also do something like this: A of 2 plus A of 0, then we are directly getting answer 8. So A of 2 is 5 and A of 0 is 3, and we are trying to add both the elements, so we can directly perform mathematical operations from here only. Now let's take one example for a 2D array. So let me create a markdown for 2D array. Now I'll make one 2D array. Let's name this B. So np dot array. And how do we make 2D array? By giving two lists or two one-dimensional arrays. So what we'll do, this will contain 1, 2, 3, and this will contain 4, 5, 6. So this is another two-dimensional array. Now what I can do to access the element, okay, let's increase the number of elements into this 2D array for better examples. So I'll add 2 more elements in each of them, and here I can start with 6, 7, 8, 9 and 10. So it goes 6, 7, 8, 9 and 10. So a small example can be, let's say if I want to access the element that is present in the second row and fifth column. First of all, I'll try to print this array. So I'll write B, and we want to, okay, let me run this cell again, and if I run it again, so now we have this 2D array that contains these elements. Now if I want to, let's say, access element from second row and fifth column. So I can write second row and fifth column, And then, so what I can do, I can write something like b1 2 4. So what it will do, it will give 10. So this is the first row for the array and this is the second row. So we are trying to access second row and fifth column. So this is the fifth column, 1 2 3 4 5. Now we can also see what this does, the first row and second. So it goes like 0 1 2. So this is the working of indexing in arrays. I hope you are clear with both the examples. This is how we try to access elements from a 2D array, and this is how we work with 1D arrays. So now moving on to the next concept. Thank you for watching the video. If you have any doubts or queries, then you can write down in the comments. Thank you. And welcome to the next video in the section of NumPy. In this video, we'll understand about array iterating. So let us start. Iterating arrays. First of all, let us understand basically what iterating in Python means. So basically, we try to use a loop and go through all the elements present inside that array. So iterating means going through elements one by one inside that array. As we deal with multi-dimensional arrays in NumPy, we can do this using a basic for loop that we use in Python. So this is very clear. For iterating the arrays, we are going to use a basic for loop. Now, if we iterate on a 1D array, it will go through each element one by one. So let's see this with the help of a practical code example. So here I have a sample code. I have made one array arr np.array, and it is a 1D array that contains 3 elements 1 2 3. Now it's a simple Python for loop, nothing advanced. We are just working on a array using that for loop. So for x, that is the element or the elements that are present in the array, for x in arr, print x. So basically this will print all the elements present inside that 1D array. Now let's talk about iterating on 2D arrays. So again I have one array, and this time it's a 2D array. As you can see here, I have two dimensions. The first one contains 1 2 3 and the second one has 4 5 6. Now for this particular code example, the syntax of the code remains exactly the same for x in arr and print x. So it will print both the dimensions of the array. Now this will be very clear to you when we move next to the practical section. As of now, just understand this code. Now the difference between iterate on each scalar element of a 2D array and iterating 2D arrays. So let's move to the next slide and I'll understand. So here, if you look very carefully, I have again a 2D array. Now this time what I'm doing, my goal is to iterate over each individual scalar element that is present inside this array, not like the every dimension of a 2D array. So this is a different thing and this is a different iteration. So let's understand this. Iterate on each scalar element of a 2D array. So for x in arr, now for y in x. So x basically, by using the first for loop statement for x in arr, this gives you both the dimensions stored in x. Now again what you are doing for y in x, so basically for y in each dimension of this entire 2D array. So the dimensions of the 2D array are already stored in the x with the help of this first statement. Now again we are using a nested for loop and writing one more for statement. So for y in x, now again we have the access to the each individual scalar element present inside that particular dimension. And now finally we're printing y. So I hope this is very clear to you. Now let's move to the practical section and try to implement what we have learned over here. So let us start with the practical implementation of what we saw in the presentation. So first of all, let me import numpy as np. Now what I will do, I'll make one array arr. First of all, I'll show you how to iterate over a 1D array. So np dot array, and this will contain 3 elements 1 2 3. So this is our array arr. Now what I'll do, for I in arr, and then I'll print I. So what this will do, this will print all the elements of the array arr that we have made. Let me show you one more time. Let me add 4 and 5, two different elements, and now this time it will show all 5 elements present inside this arr. So this is just a simple for loop implementation of Python. In Python we usually work with for loops to iterate over a list or a string or other data structures that we have in Python, but here we are simply using that for loop to work with the numpy array. Now the example that we saw here was for a single dimensional 1D array, we can also take this to the next level and have a look on a 2D array. So ARR2 and NP dot array, and this time what I'm going to do, I'm going to make a 2D array 1 2 3, and here I will have 4 5 6. So this is a 2D array. I'll try to iterate over this. Okay, so let's take a new variable for j in ARR2, and if I try to print j, so this j is giving me basically the two dimensions that I have for this array. Now by using this syntax, what I did basically, I iterated over the dimensions that are present inside this 2D array. Now if I want to iterate over each scalar element, each individual scalar element like 1 2 3 and so on that is present inside this 2D array, so I have to use a nested for loop. So basically what I can do, for j in ARR2, for b in j, and then I'm going to print b. So what this will do, this will give me the output as I got over here. So now I'm basically able to access each and every individual scalar element that is present inside this array. So let me explain what is going on over here in the syntax. So with the help of this first for statement, we are storing both the dimensions inside j, both the dimensions of ARR2 inside j. Now again we are using a nested for loop. This time I'm using for b in j, I'm making a new variable and I'm iterating over this j. Now after the execution of this statement, this j contains both the dimensions of this array, and each dimensions contains its original scalar values that were present over there. Now if I iterate over j, I'm simply getting all the scalar values that were present inside this entire 2D array. I hope you are very clear with this concept now. Let's move to the next video. Thank you. Hello and welcome to the video on array slicing. In this video, we'll understand the basic concept of array slicing in Python or NumPy. So first let us understand how slicing works in Python. So slicing in Python means taking elements from given one index to another index. So we pass this slice instead of the index like that we saw in the last video. So in indexing, what we did, we were just giving one particular index position and we were trying to access that particular element present on that position. But instead of that, we'll try to pass the start and end both the indexes, and the elements that are present between them will be returned by NumPy. We can also define the step like this. So here we were just providing the start and end position, but what we can also do is we can give the step. So if you don't give the step, automatically it is considered as 0, but if you provide the step, then it will skip the number of elements that you mentioned in the step. So, and one more thing, if we don't pass the end, it is considered as the length of that dimension, and if you don't pass the starting position, then it is automatically considered as 0, because the index of the first position in NumPy is considered as 0. So if you don't mention anything at the start, it will automatically consider it as 0. And for the step, if you don't pass any step, for example in this scenario, if you are not giving any step, then automatically 1 for the step is considered like it won't jump any elements. So let's take this example. Here we have a 1D array that has elements from 1 2 3 4 5 6 7, and now if you are giving ARR of 1 colon 5 into the square brackets, now what it will do, this is the start position, and at the start position we are giving the index value of 1. So 1 is this element because the index starts from 0 and this is the 1, and 5 goes to 0 1 2 3 4 5, this is the fifth position. So this will slice all the elements present between these two indexes. This will be more clear to you when we run all these programs in the Jupyter Notebook, but till now just understand the concept in this presentation, and then after this presentation part we'll try to perform the practical implementation in the Jupyter Notebook. Now here we have one example for the step to determine the slicing. Now we want to return every other element from the index 1 to 5. So basically it will jump one element. So this is the start position, this is the end position, this is the step. If you want to return every other element from between these two indexes, then simply provide 2 in the step. So this is an important thing that you can remember. Now let us understand how do you slice 2D arrays. So from the second element, slice elements from index 1 to index 4. Now as you already know, a 2D array is a combination of two different 1D arrays in NumPy. So this entire thing is a 2D array, but as you can see, while we have written it as a combination of two 1D arrays. So this thing or this list is a single 1D array, and here this we have another 1D array. So the index for this entire first array will be 0, and the index for this entire second array will be 1. So whenever I am writing that I want to work with the array that is present on index position first, so NumPy will consider this array, and whenever I write 0 instead of 1, that will be considered as first array. So here we are trying to access the elements or slice the elements from the second element or second array. So basically we are working with this array. So here we are writing index 1, and then this is the start position into this array. So this goes like 0 1, so from 7 to the fourth position 9. So this is how indexing works for 2D arrays. Now let us move to the Jupyter Notebook and try to perform the practical for this NumPy slicing. So let us start with the practical implementation of array slicing. Import NumPy as np. Then I'll make one 1D array. So let's name it A and np dot array. Inside this 1 2 3 4 5 6 7 8 9. So this is one 1D array in NumPy. Now what we can do, I can just slice it from, let's say, 1 colon 5. So what this will do, this is the first index position, and so the slicing will start from here. So 2 3 4 and 5, 0 1 2 3 4. One more thing, one more important thing about slicing, this is very similar to how lists work in Python, is that the index position that is mentioned at the start, or the element that is present on the index position from the start, will be considered while printing the answer. So, and the element that is present at this index or the end index position will not be printed. So because the index goes like 0 1 2 3 0 1 2 3 4 and 5, and the element that is present at the fifth index position is not printing, only the 4 elements are printing. We can also take one more example, let's say 2 to 7. If I run this now, 0 1 2 3 4 5 6 7 8. Now what it will do, the element that is present at the second index position, that is 3, will be printed, but the element that is present on the 7th index position, that is 8, will not be printed. The printing will be done only from this to this part. I hope this is clear. This is very similar to the Python lists. Now let's try one more thing. Let's say a of 4 colon. So what this will do, it will start printing the elements from index 4, 0 1 2 3 4. So it will start from here, and as discussed in the presentation, if you don't mention anything at the end, then it will print the entire array. Till it will consider the end position as the length of entire remaining array. We can also do something like this. So colon and 5. So what it will do, if you don't mention anything at the start position, then it will consider from the first index position, that is 0. Now we'll also try something with the step. So 1 colon 6 colon 2. So what this is doing, it will skip one element and it will print every other element. So from index 1 we have 2, and we are jumping one step because we are providing the step of 2. So it will skip 3 and it will print 4. Now again it will skip 5 and it will print 6. So this is how the step function in NumPy works. Now what we can do, we'll just try to slice a 2D array. So let me give a markdown, slice a 2D array. We'll make one 2D array and let's name this b is equal to np dot array, and inside this 1 2 3 4 5, and the second one will be 6 7 8 9 and 10. So this is our 2D array. Now what we can do, we can write something like this, b of 1 comma and 1 to 4. So what this will do, the first row has index of 0 Consider a 2D array as a matrix of rows and columns. So the first row will have index of 0 and the second row will have index of 1. Now at this position we are providing just the index of the row. So as we are writing 1, so it will consider this second row. Now the row selection is done. Now moving in, it is starting from first position or the index number 1, that is basically the second position in the array. So it is considering from this to this 1 to 4. So this means second row and 1 to 4. We'll take one more example, b of 0 comma and this goes 0 to 3. So what it will do, 0 means first row and again here 0 means the first index position. So it will start from 1 and it will go to 3. So this is how slicing works in NumPy. I hope you are very clear with the practical implementation of slicing in NumPy, and let's move to the next video. Hello and welcome to this video in the NumPy section. Today we'll learn about performing searching and sorting operations on a NumPy array. So let us start. First of all, searching arrays. You can search an array for a certain value and return the indexes that get a match. So to do that, to search an array, use the where method. So we have a where method in NumPy. To search that, we can use a where method. So what it will do, here I have one array ARR. Now we want to do that x equals to, we basically want to store the value that we are searching inside this new variable called x. np.where ARR is equal to 4. So if you have a look very carefully on this array, 4 is present at 3 different positions. So the index starts at 0, 1, 2, 3. So 3, 5 and 6. So 4 is present at 3 different indexes. So what this will return, it will return an array of 3 indexes. So 3, 5, 6. So 3, 5, 6 and this will be stored into x. So basically what where method does, for example, if I, instead of writing 4, if I write 5 over here, so what I will get, 0, 1, 2, 3, 4. So it will return 4. That is the index of the position where the element 5 that I'm writing over here is present. That's very simple. So this is about where method that is used to perform search operation on a NumPy array. Now we have one more example. So in this example, what the question says, find indexes where the values are even. So this is a simple programming logic that we use to solve a lot of programming questions. So if we want to find the numbers that are even, so we just simply take mod 2 equals to 0. Every even number should is perfectly divisible by 2. So all the even numbers, all the indexes of the even elements, all the index positions of the even elements that are present inside this array will be returned and it will be stored. So this is another simple example. Now after learning about the where method and how to perform the search operation inside the NumPy array, now let's understand about sorting of NumPy array. So sorting means putting elements in an ordered sequence. Very simple. Ordered sequence is any sequence that has an order corresponding to elements like numeric or alphabetic. So we can perform a sorting on array containing numeric values or the alphabetic values, ascending, and we can also do the ascending or descending order. Now the NumPy ND array object has a function called sort. To perform the search operation, we had this function called where. To perform sorting, we have this function called sort, and it will sort the specified array. Now let's take one simple example. I have one 1D array. It contains 4 elements. Now if we just want to sort this array, I have to simply call the sort function on this array, np.sort, and inside the sort function I have to give the name of the array that I want to sort. Fairly simple. Now for example, if I have a array containing alphabets, so if you observe the first letter of all the elements, apple, banana, cherry, so this has first letter as A, this is B and this is C. So it will be sorted in ABC fashion. So first we'll have apple, then we will have banana, and then we'll have cherry. So this is how sorting works on a alphabetic array. Now I'll hope you are clear with the basic concepts. Now we'll move to the practical section and try to implement all the concepts that we have learned in the presentation. So let us see the practical examples of searching and sorting a NumPy array. First of all, let me import NumPy as np. Then I'll make one single array. A is equals to np dot array, and this will be 1 2 3 3 4 5 8 5 and 10 and 20 and 1. So this is one numpy array that I have made. Now x will be np dot where. Now we are using the where function to search the element. Now which array we want to search is the A. We are searching the elements from array A, and the value that we are looking for is, let's say, 1. So now the index position where 1 is present inside this array is stored inside this x, and if I just try to print the values of x, so 1 is present at the 0th index and 1 is again present at the 10th index. Now what I can do, y will be np dot where, and let's say a is equal to 4. So if I try to print the value of y is present on the 4th index. 4 is present on the 4th index, so 0 1 2 3 4, so 4 is present on the 4th index. So this is about the where function. Now let me show you one more example. If I want to do something like this, let's say ans is equal to np dot where, and a %2 is equal to 0, and if I try to print ans, now I'm getting the index positions of all the elements that are even numbers, because even numbers will give remainder 0. Even numbers will give remainder 0 when you divide them by 2. Now let's perform a sorting operation. So to perform the sort operation, we just have to call a simple method np dot sort, and what this will do, let's pass a inside this np dot sort. Now the array is completely sorted in ascending order. Let me make a new array a2, and let me give np dot array, and I'll just give some random values 44 12 90 76 and let's say 55. And then if I want to perform the sort operation on this array, so np dot sort, and I'll give a2 inside this np dot sort. Now this is again sorted. Now we'll also take a look at the example in which the array does not contain the numerical value. So I'll make a array a3 and np dot array, and let's say I have mango, and then I have let's say papaya, and then I have apple, and here I have orange. And if I want to sort this array, np dot sort, and I'll give a3. So as you can see, this is sorted based on the first letter, so A, M, O and P. So this is how searching and sorting works in a NumPy array. I hope you are very clear with this concept. Now let's move to the next video. Thank you for watching. Hello and welcome to the first video in the Pandas video tutorial series. In this video we'll start our learning journey of Pandas. So before moving on to the core technical steps of Pandas, let me give you a very important note that Pandas is one of the most used tool or library that we'll be working with when we perform data analysis or visualization. So mostly the data sets that we have, or the CSV or Excel file set we'll be getting to analyze, will firstly store them into a Pandas data frame, and all the operations will be performed later. So this is the core of your data science journey, so please learn it very carefully. Now first of all, let us understand what is Pandas. So Pandas is a Python library used for working with datasets. As I told you, all the datasets that we work with will be stored in a Pandas data frame. We'll cover different data types that Pandas offers, like series and data frames, etc., in the next few videos. But as of now, data frame is the most important thing in the data analysis lifecycle. Now it has functions for analyzing, cleaning, exploring and manipulating data. So once we store the CSV or Excel data into a Pandas data frame, then we can perform cleaning, exploring and we can analyze the data. Now the name Pandas has a reference to both panel data and Python data analysis, and it was created by Wes McKinney in 2008. So this is just a basic introduction about Pandas. Now why should we use Pandas? As I told you, Pandas allows you to analyze big data and make conclusions based on statistical theories. So we can also clean messy data sets very easily in pandas and make them readable and relevant. Now relevant data is very important for data science purpose. So to get a decent conclusion or a conclusion that is impactful or meaningful for your organization, it is very important that we analyze the relevant data. Now what can pandas do? Pandas gives you answers about various things like, is there a correlation between two or more columns, or what is the average value for a certain column, max and minimum values of the column. Now pandas are also able to delete the rows that are not relevant. We can also remove the rows or columns in the data that are not relevant. We can also treat the missing values or empty columns of the data. Now this portion is called data cleaning. This we'll see in the next module, but as of now, just remember this thing. Once we have loaded the CSV in the pandas data frame, all these operations can be done. Now how do we install pandas? First of all, use the following command to install pandas on your system. Pip install pandas, very similar to numpy and matplotlib that we've already seen. Now I'll show you the basic installation and working of pandas in the Jupyter notebook. So let's move to the practical section. So let us start with the practical section of pandas. First of all, let me show you how do you install pandas on your system. So pip install pandas, just write this command, and I already have pandas installed on my system, so it will show requirement already satisfied. Now to start working with pandas, first of all I need to import pandas, and with the alias pd. This is the standard alias that everyone follows around the globe. Now after writing this line of code, pandas is imported. Then the usual life cycle of a data science or ML project is that first of all you have a data set. You need to check whether the data set is cleaned, or maybe it has some missing values, or etc etc. So data cleaning and data preparation process is done with the help of pandas. So usually you have a data structure in pandas that is called data frame. So you what do? You have this function called pd dot read underscore csv. This I'm just giving you a little introduction. I'll cover each and every part of this code in detail in the next few videos. Just as of now I'm giving you a little introduction. So you provide the path of the csv file or the excel file or whatever dataset that you're working with. What this will do, it will store the entire csv using this read csv into this pandas data frame, and then you can perform all your data analysis or visualization or whatever you want to do based on the functions that are already given in the pandas. Now once you have the clean data, then you, after doing all the analysis and visualization, you just run ML models on that data for your prediction. That the machine learning part will cover later in this course, but this is the entire life cycle of a data science or a ML project. So I hope you are very clear with this. Now let's move to the next video and understand pandas in detail. Thank you. Hello and welcome to the video on pandas series. Series in pandas is just like data frame. It's just another important data structure of pandas. In most of our data science projects we'll be working with the pandas data frames, but in this just a little video I just want to give a small introduction about what is series. So just you should know there's something called series that exists in pandas. Now what is a series? A pandas series is like a column in a table. So data frame, basically you will have the entire table. Series is just like a column inside that whole table. Now it is a one-dimensional array holding data of any type. So the column just acts like a one-dimensional array, and it can hold any type of data. It can be numerical data, or you can also store English alphabet. Now sample code for pandas series. First of all you need to import pandas as pd. Now here we have a simple Python list. Let's name it A. This list contains 3 elements, 1, 7, 2. Now I want to make a new pandas series, so let's name it myWhere. This will be a new pandas series, and this will be equal to pd dot, we have a series function, and inside this series function I'll give this list A. So this will be converted into a pandas series, and it will be stored into this variable called myWhere. Fairly simple code. And now when you try to print myWhere, you will have a pandas series. So I'll also show you this. Will run the entire code when we move to the practical section, but this is just a core concept. Now we can also store key value objects as series. Let's understand this code also. Again, import pandas as pd. Now here I have a Python dictionary. So day 1 is 420, day 2 380, and day 3 390 again. In the previous code we were having a list. This time we are working with a dictionary. Nothing changes. Now here again I have pd.series function, Inside this, I'm giving sample, the name of the dictionary that we have. So I just pass the dictionary in this argument, and it will be stored into myvar, and I will have a pandas series. So these are the two examples of a series. I showed you an example on a Python list, and then I have a key value object as panda series. Now let's move to the practical section and try to implement both the examples on a Jupyter notebook for better understanding. So now I'll show you the practical implementation of Panda series. First of all, let me import pandas as PD. In the next cell, what I'm going to do, I'll just make a simple Python list. Let's say L1, and this will contain 3, 6, 8, 10, and 30. It contains 5 different elements. Now I'll make a series 1, let's say S1, and this will be PD dot. I have this function called series inside pandas, and I just have to pass L1 the list that I have already made. Now if I run this, I have a series in S1, and let me show you by printing it. So S1 is just a pandas series. This is the index number. The index number that we already discussed in NumPy, that the index starts from 0 and it goes on. So 3 will be having index of 0, as this is the first element of the series. Now 6 will be having the index 1, this is the second element of series, and so on and so forth. If I add few more elements, let's say 22, and then if I run all the cells again, now I have a new element at fifth index or the sixth position, and the value is 22. Now let me show you one more example as key value objects in series. So what I'll do, I'll make a dictionary D1, and this dictionary will have, let's say, the first value is 10, the second value is, let's say, 100, and the third is 1000. So this is a dictionary D1, and again I want to make another panda series from this dictionary. So let's name it S2, and S2 will be PD dot series, and this time I will pass D1 into the series function. So again I have a panda series, and this time let me print and show it to you. So the keys of the dictionary will become the index positions of the panda series. So this is the main difference between these two approaches of the panda series. I hope you are very clear with the concept of series in pandas. Now in the next video, we'll discuss about the most crucial concept of a data science journey, that is the pandas data frames. So let's move to the next video. Thank you. Hello and welcome to the video on pandas data frame. This video can be considered as one of the most important video in your data science journey, because in this video I'll introduce you to the pandas data frame, which is the basic building block of your entire data analysis and ML journey. So first of all, let us understand what is a data frame. A pandas data frame is a two-dimensional data structure like a two-dimensional array or a table with rows and columns. So simple understanding that you can fit in your mind is that a pandas data frame is a two-dimensional data structure, and it also has rows and columns. So the first dimension is for rows and the second dimension is for columns. So here I have one example. Consider this as a pandas data frame. So as I also explained in the last or maybe last to last video, that your typical data science project will look something like this. You will be given a CSV file or a data set in any format, and you have to just load that entire CSV or Excel file into a pandas data frame. So initially this will be a CSV or Excel file that will have the first column of registration number, second column will be of name, and third column will be of marks. And in the rows you will have all the entries for the particular columns. Like this column will have entries Steve, Matthew, the names of students or people or whatever it is. So in your project, what you will be doing, you will be storing the data that you received in the form of CSV or an Excel file into a pandas data frame, and onto the data frame will be performing all the analysis that I'll show you in the next few slides and in the next few videos. So here I have a sample code. For the purpose of this video, I'll be not taking any external Excel or CSV file, but I'll also show you some example of that in the next video. In this video, what we are doing, we are making our own data set, and this is a key value pair. So the first column will be calories and the second column will be duration, and these are the entries for both the rows and columns. Now we have made our own sample data, and as already seen in the last video, that we have a function called pd.series that converts this simple Python dictionary into a Python series, panda series. Similarly, we have a function called pd.dataframe that will convert this simple dictionary, Python dictionary, into a pandas data frame. So pd.dataframe and in the argument of this function will give this data, and it will store it into a pandas data frame. And so we have a data frame ready. So this is the sample code for making a simple data frame from a Python dictionary. Now as the result, you can see initially we were having the calories and duration separately stored into a Python dictionary. Now we have this entire data frame in the format of rows and columns. So the calories and duration are the columns, and these are the entries in the form of rows for the particular columns. So this is how you create a simple pandas data frame in Python. Now let's see one important feature of pandas, that is how do you locate any particular row. So as you can see from the result above, a data frame is just like a table with rows and columns. So it is just like a table with some rows and columns. Now pandas uses the loc attribute or the locate attribute to return one or the more specified rows. If I want to access any particular row from the data frame, then I can use df.lock. Now df is basically the data frame that we are working with. So df is equal to pandas.data frame. Now this entire data is stored into a data frame. So all the functions will be applied on df, the data frame. So data frame dot locate the 0th position. So this is how you work with basic pandas data frames. I hope you are very clear with the introduction. Now let's move to the practical section and try to implement all this in the Jupyter notebook. So let us start with the practical implementation of the basic pandas data frame that we saw in the presentation. Let me import pandas as pd. Now I'll create my sample data. I'll show you how to work with the CSV data given to you in the next video, but for the purpose of this video, let us work with the sample data and we'll create it on our own. So let's name it week days, and this will contain Sunday, Monday and Tuesday, and then we have another key value pair, let's say test score. So what this will have is 10, 20 and 30. So this is our sample data. Now to make a data frame out of the sample data, I'll write df. This is the data frame variable that I'm making, and I have this function called pd dot data frame, and inside this data frame I'll pass my sample data. So I have a data frame ready. If I just try to print df, now as you can see I have the output in a tabular format. So the first column is of weekdays and the second column is for test score. So Sunday, Monday, Tuesday and 10, 20, 30. Now this is a simple pandas data frame that we have made. Now to access any particular row of the data frame, so we have this locate function. So I can write df dot loc, and if I pass the index 0, I'll get the first object, test score and 10 on Sunday. So weekdays, Sunday, test score is 10. So this is the first column. It has value Sunday and the test score is 10. Now we also have some other functions like head, tail, describe, info, etc. That will cover in the next video when I'll show you how do you work with the CSV data and how do you store into a pandas data frame and perform all those operations. So for this video, this is it. Now let's move to the next video. Thank you. Hello and welcome to the video on pandas read CSV. So how do we read CSV files and store them into the pandas data frame so that we can perform our analysis and visualizations? So a simple way to store big data sets is to use CSV files, separated files. CSV files contains plain text and it is a well-known format that can be read by everyone, including pandas. In our examples, we'll be using a CSV file called data.csv. So we have this function called read underscore CSV in pandas, and inside this we can give the path of the CSV file, or basically the location at which it is present on our local machine. So import pandas.pd, import pandas as pd. Now df, a data frame that we want to make, pd dot read underscore CSV, and here I'll give data.csv. I'm not mentioning any other location like desktop slash xyz folder slash data.csv, because I'm assuming that the Jupyter notebook that is running and your data file, the CSV file, both are present in the same directories. If so, then you can simply give the name of the file .csv and it will work directly. I'm repeating the condition one more time. The location of your Jupyter notebook and the location of your CSV file should be same, then this will work. You just have to give the name of the file .csv, and this entire tabular or Excel or CSV file will be stored into a data frame, and then I'll simply print a data frame. So I'll show you this example. So pandas.read underscore CSV, and I have a file called schedule.csv. I'm just giving it over here, and then if I want to print the entire CSV file, I'll get the entire data or the Excel or CSV format that it was originally having. So it will be visible on the pandas data frame. So now let's move to the Jupyter notebook and see the practical implementation of pandas read underscore. So now I'll show you the practical implementation of read underscore CSV in pandas. In the same directory, I'm having one dataset called airport.csv, and I will store that airport.csv into a pandas data frame, and I'll show you how to do that. So first of all, import pandas as pd. Next, I will make one data frame variable. Df will be equal to, the function is pd.read underscore CSV, and the name of the file is airport.csv. Make sure that this CSV file is present in the same directory where the Jupyter notebook is running. Now if I just write df over here, so as you can see, I'm having the entire data frame, that is 337 rows and 20 columns of the airport.csv file stored into my data frame. So this is how you work with CSV files in pandas. You can also explore how do you store the JSON or the Excel files. Pandas also supports those formats. So the basic functionality will remain the same. The location of the file, if you want to just simply write name.csv, should be in the same directory as your Jupyter notebook. So I hope you are very clear with this part. Now let's move to the next video, and I'll show you the basic functions that you can perform on the data frame that contains the CSV. Thank you. Hello and welcome to the video on analyzing data frames. In this video, we'll learn about some important functions and features that pandas gives us to analyze data frames. First of all, viewing the data. So one of the most used method for getting a quick overview of the data frame is the head method. The head method returns the headers and a specified number of rows starting from the top. This is a sample code. Import pandas as pd. Now we are making one data frame and I'm storing data.csv by the read CSV function. And now we are having one data frame df. To view the top 10 rows of that particular data frame, we can write df.head and into brackets we can give 10. Now there is also a tail method for viewing the last rows of the data frame. If you want to view the top rows, then you can use the head method, and if you want to view this last few rows of the data frame, then you can use the tail method. The tail method returns the headers and specified number of rows starting from the bottom. The same thing can be done with the tail method. Moving on, the next thing we are interested about is the info about the data. So the data frame object has a method called .info that gives you information about the data set. For example, df.info, you can call this, and now this will return the basic information about the data set. Like there are 169 entries for each of the columns and 164 for the calories. These are the column names. We don't have any null values in the columns, non-null, and this is the data type. So calories may contain some decimal point or float type values. That way it is showing float 64. all these three, duration, pulse and max pulse, only have the integer type values. That's why we have the data type as integer 64. So this is about the info method. All this I'll show you in the practical implementation on the Jupyter Notebook once we are done with the presentation. So next we have the describe method. So the describe method returns description of the data in the data frame. If the data frame contains numerical data, this is very important. The describe method will only work on the numerical data, and the description contains these information for each column. So you will get this these basic statistical details for all the numerical columns that you have on your data frame. So count, basically the number of non-empty values, mean, the average or the mean value for that entire column, the standard deviation, this is the minimum value. Now you have the 25th percentile, 50th percentile and 75th percentile. So, and the maximum value. So these are the basic statistical measures that the describe method returns for the numerical column. Here is one example. So we have one data frame called frame, and I have stored ratings.csv into that data frame. Now if I call the describe method, I'll get all the information. So these are all the numerical columns that are present in the ratings.csv, and this is the information for that particular column. So the average value for rating is 1.19 and the average food rating is 1.2. This is the mean. Now the standard deviation for rating is 0.7. So by using the describe method, you can get a very quick overview of all the numerical columns of your data. Now let us understand about the correlations of the data. So a great aspect of the pandas module is the correlation method. So it is CORR method. The core method calculates the relationship between each column in your data set. So to work with this, you can simply write df.core. Now correlation is very important to understand the a relationship among different columns that are present in your data set. So for example, if you see, a perfect positive correlation will have the value of 1 and a perfect negative correlation will have a value of -1. And if the data set is if those two particular columns are non-correlated, then they will have value somewhere around 0 or slightly plus minus. By doing this, we can have a very good idea. Like for example, here calories and duration have a very good correlation of 0.92. So this will be very important when we move to the machine learning part, and this will be very helpful. The correlation analysis will be very helpful when we try to deploy or make our machine learning models. So this is a very important and powerful feature, the correlation that pandas gives us. So I hope you're clear with the basic functions that pandas gives us to analyze different data frames. Now let's move to the Jupyter Notebook and try to implement all the functions that we've seen in this presentation. So now I will show you the practical implementation of all the functions that we saw in the presentation. Let us start. Let me import pandas as PD. Now I will use the same airport.csv file. So df pd.read csv, and I'll have airport.csv. So to check that, I'll write df, and I have all the values that are stored in the report.csv file. So I have 337 rows and 20 columns. Now if I want to view the top 5 data, all the rows that are present in the reports.csv, so I can write df.head. It will give me top 5 values or the top 5 rows present in that file. And if I want to view, let's say top 10, so I can write df.head and 10. I can mention 10 in the argument. So this is about the head. Same thing can be done for the last few rows by using the df.tail function. If I normally use df.tail function, it will show me the last 5 rows of the data set. If I want to view more number of rows, so I can specify it inside the brackets. Let's say I want to view the last 7 rows. So I can write 7 and it will return last 7 rows of the data frame. So this is about the head and tail. Now let us have a look on the info. So I'll write df.info and it will give me the basic information about all the columns present in the data set. So ID or intent, this is a categorical feature, this is a numerical feature. This is showing object, that's why I can say it's a categorical feature. This is the count and not null and the name of the columns. Now we can also see this method called describe. It will describe all the numerical features present in the dataset. So all these are ID, latitude, longitude, elevation, year built, year tier score, and all these are numerical features. So we are getting the basic information or the basic statistical data about all these features like count, average, standard deviation, minimum, maximum, 50th percentile, and so on and so on. So this was about the describe method. Now I hope you are clear with all the methods that we discussed in the presentation, and I've also shown you the practical implementation. So now let's move to the next video. Thank you. Hello and welcome to the first video in the section of Matplotlib. In this video, we'll learn about the basic terminologies and keywords that are used in Matplotlib and what Matplotlib is all about. So let us get started. First of all, Matplotlib is a Python plotting library that is used for making various visualizations while we are performing data analysis. So to work with Matplotlib, first of all we need to install that, and to do that you can run this command called pip install matplotlib. This command will install Matplotlib on your system. I already have Matplotlib installed on my system, so this will probably show requirement already satisfied. Now to work with Matplotlib in your Jupyter notebook, we need to import it as other libraries. So what we'll do, we'll write, as you can see here it says requirement already satisfied. Now here we can write import matplotlib dot pyplot as plt. Now most of the Matplotlib utilities lie under a submodule called pyplot, and we are importing that as the alias plt. So this is, we import the Matplotlib. Now starting before, we'll also cover different type of plots or graphs that you can make with Matplotlib, like line chart, bar chart, scatter plot, pie chart, etc, etc. But for this video I'll just show you a simple line plot, and to plot a line we need some numerical values, so we will also import numpy as np. Now what we can do, a line has two axes, a plot has two axes, that is the horizontal and vertical axis. So the horizontal axis is called x-axis and the vertical axis is called the y-axis. So what we'll do, to plot the points on x-axis, I'll write x is equal to np dot array. I'll make a numpy array and I will, let's say, give 0,6, and y will be again a numpy dot array, and here I'll give let's say 0, 80. So these are my 2 points on x and y axis. Now to make a simple line plot we have a function called plot. So we can write plt and we can call this plot, and here we will pass our x-axis and y-axis. And then to finally show the plot we have this function called plt.show. So as soon as I'll run this cell, I'll get this output. So this is x-axis, these are the 2 points, 0, 0 is here and 6, 80 is here. On the y-axis you can see we have coordinates starting from 0 to 80, and on the x-axis you can see we have coordinates starting from 0 to 6. Now we can perform various designing and other editing on this plot, like we can change the color of the line or we can change the pattern of the line and all that, but all that we'll see in the next video. As of now this is just the introduction video. The important thing to remember is we'll be using Matplotlib for most of our data visualization part when we'll move to the practical or more sort of a complete case study or project analysis. This is the basic introduction for Matplotlib. The important thing for you to remember is that plt.plot function and plt.show functions, these are the functions that we use to plot our graphs in Matplotlib. I hope you are clear with this concept. In the next video I'll show you different type of plots that we can make in Matplotlib and somewhat editing about those plots. Thank you. Hello everyone and welcome to the next video in the section of Matplotlib. In this video we will learn about different type of plots that are available in Matplotlib. We'll try to cover the most important ones that will be very helpful in your data analysis and visualization journey. So first of all, let us start the tutorial with the line chart. So we'll just import matplotlib.pyplot as plt as already discussed, and I'll also import numpy to generate an array based on integers that will be useful while making our line chart. So import numpy as np. I'll run this cell and we'll wait for it to execute. It will take some time to import the required modules, and then we'll start. So it is done. Now we'll start. So what we'll do, we'll first generate some points that will be used to plot the line. So I'll make one numpy array called points, and to make an array in numpy we just use the array function, and inside this I'll pass a list. So let's say 4, 7, 2, 10 and 13. So these are the points that will be used to plot our line. Now next what we'll do, to plot a line plot in Matplotlib, the function is plt.plot. So this is the function that is used to plot a line. Now we'll pass, as we want to plot the line for this array, the data that is present in this array. So I'll pass this array over here, and then it will take some time to plot it, and finally the plot is ready and it's processing. So as you can see, it's now visible. So first point is 4, that is here. The next point is 7. The third point is 2. The fourth point is 10 over here, you can see on the y-axis, and the fifth point is 13. We can also write plt.show to see the plot very clearly. So plt.plot function is used to plot the graph, and plt.show function is used to see that graph. Acha, we can make one more change over here. So what we can do, we can also write something like this. So plt, okay, let me make 8 to a new array np.array, and this time I will pass 1, 2, 3, 4, 5, 6, and then plt.plot 8 to, I want to plot this over here, and this time I want to change the line style and I want a dotted line. So you can use this line style feature to change the type of line, and then finally I'll write plt.show. If I run this cell, this time as you can see I'm getting a dotted line. We can also try one more variation. Instead of dotted we can type dashed, so I'll get this type of line. So I hope you are clear with the line plot. We'll also see many different types of line plots when we work on real-time data sets and the data analysis part, but as of now, just for introduction purpose, these are the only type of line plots that we're going to see. Now let's move to the next type of plot that we're going to see, that is the bar chart. So again, to plot a bar chart, what we'll do, we'll take two different types of data, that one will be a categorical and one be a numerical. So I'll make two different numpy arrays, one for the x-axis and one for the y-axis. So for x-axis, what I can do, np dot array, and here what I can write, x comma y comma z comma w, and for y-axis, that is our vertical axis, what I can do, np dot array, and here I can give some random numbers, let's say 25, 30, 27 and 22. So these are the two different data x and y coordinates that we are going to. Okay, so what okay, I have forgot to add the square brackets over here, and I'll put it over here, and again also for the y-axis I just have to add the square brackets. So that's why we were having one error. Now to plot a bar chart, we'll write plt dot bar. For line chart we were using plt dot plot, and we'll pass both x and y axis, and finally we can write plt dot show. So this is how you will get a bar chart. On the x-axis, as you can see, we have 4 different values, x, y, z, w, and on the y-axis we have 25, 30, 27 and 22. So this is the bar chart. The next chart that we are going to see is a scatter plot. So in bar chart we are working with one categorical and one numerical feature. In scatter plot we'll work with both the numerical features. So what I can do, again I'll make 2 different arrays. So let's say x1 np dot array, and this time I'll give some random values 20, 15, 11, 7, 8, 10. So I'm giving 6 different values, and y2 will be, okay, y1 will be np dot array, and I'll again give some values, let's say 2, 7, 15, 8, 10, 12. So again 6 values for both x and y. And what I'll do, to plot a scatter plot we have to write plt dot scatter, and here I'll pass both x1 and y1, and then I'll write plt dot show. So what this will do, this will plot a scatter plot. So on x-axis we have our 6 values that we give, 20, 8 and all the values, and on the y-axis we have all the values. So this dots or the points that we have on the graph represent 20, 2. So the first value will represent 20, 2, 20 on the x-axis and 2 on the y-axis. For example, this value will be 15, 15. So this is how the scatter plot works. We work with both numerical features. Now the next chart that we have is a pie chart. So what we'll do, again I'll make one array, let's say p, and np dot array, and let's give 30, 20, 25, 20, and what I'll do, plt dot pie, and I'll plot p. So this is how you get a pie chart in Matplotlib. And the last final chart that we are going to see is a histogram. So to work with histograms, what I can do, again I'll generate some random values in NumPy. So h1 will be np dot random dot normal, and let's say I just give over here 170, 10, 250, and then plt dot hist. This is the function that we use to plot a histogram, and I'll pass h1 over here, and as you can see we have a histogram ready in Matplotlib. So these were some of the different plots in Matplotlib. We'll study all the different plots in detail when we move to the main data analysis and visualization, but this was just an introduction to the different plots. I hope you are clear with this. Now let's move to the next video. Thank you. Hello everyone, and welcome to the video tutorial on Seaborn in Python. So Seaborn is another powerful Python plotting library that uses Matplotlib underlead to plot powerful and impactful visualizations. Now, first of all, let us understand how do we install Seaborn on our system. So again, by using the same pip command, we can write pip install Seaborn, and if I run this cell, I'm already having Seaborn installed on my system, so it shows me requirement already satisfied. Now the next step that we want to do is we want to import Seaborn. So I'll write import Seaborn as SNS, and I can also import matplotlib, import matplotlib dot pyplot as plt. So these are the two important libraries that we'll see. Now we are going to basically see three important plots in Seaborn. So first plot that we are going to see is the box plot, and the second plot that we are going to see is the dist plot, or the distribution plot that they call. So the dist plot, and the third plot is rect plot. So these are the three important plots that we are going to see in Seaborn. So first of all, let us start our journey of the box plot. So what I'm going to do, Seaborn already has some inbuilt datasets. You don't need to use any external CSV that we saw in Pandas data frame. So I'll load one dataset that is already present inside Seaborn library into my Pandas data frame. So I can also write import pandas as pd, and then I'll make a data frame df is equals to and sns dot load underscore dataset function. By using the load underscore dataset function, you can try to use the inbuilt datasets that are already present in Seaborn. So now I can write tips. There is a dataset of tips that is already given in present now in Seaborn. So I can see the data frame. So the dataset contains 244 rows and it has 7 columns. It gives us information about features like total bill, tip, the sex of the customer, smoker, day, time, and size. So this is the basic information. Now to plot a box plot, what we can do, we can just simply do df dot box plot, and here I can write by, so it will be day, and then I can write column that will be total underscore bill. So this will be total underscore bill, and the third argument will be grid, that will be false. Okay, so I have to write capital F over here. So as you can see, I have my box plot ready. Now first of all, let us understand what a box plot is and how we can interpret the data that we have visualized through box plot. So box plot is basically a visual representation of depicting groups of numerical data through their quartiles. These basic statistical measures that I already showed you, like you have the 25th percentile, 50th percentile, and the average, mean, median, etc., etc. So these are the basic statistical measures. Now box plot is also very important for detecting outliers in the dataset. Now the concept of outliers in the dataset is very useful when you try to implement machine learning models on the dataset. So if you are already aware about the kind of outliers that are present in different features of your dataset, so it will be very helpful to increase the accuracy of the prediction of your machine learning model. So that is why box plot is very important. Now it captures a summary of the data very efficiently in a simple box and whiskers, and allows you to compare into a different groups. Box plot summarizes the sample data using the 25th, 50th, and 75th percentile, and these percentiles are also known as the lower quartile, median, and upper quartile. So this will be the lower quartile, median, and the upper quartile. So a box plot consists of 5 things: the minimum value, the maximum, and the first quartile of 25th percentile, median, or the second quartile, or we can also call it the 50th percentile, that is the median, and the third thing is the 75th percentile and the minimum and maximum value. So this is why box plot is very important. You can detect outliers very easily with the help of a box plot. So if you are clear with the box plot, now let's move to the next type of plot that we are going to use, is the dist plot. So to do that, I'll use a new dataset, and let's use the Titanic dataset. This is a very famous dataset in data science. Most beginners have already worked on the Titanic dataset, and I'll also try to show you some important exploratory data analysis on the Titanic dataset in the next few videos. So what I can do, I can again write SNS dot load underscore dataset, and Seaborn already has Titanic dataset stored inside it, so we just have to import it inside a data frame. Now it is loading. It will take some time to load the Titanic dataset into from Seaborn to our pandas data frame. So yeah, it is done. So let's take a look what we have inside the Titanic dataset. So this Titanic dataset has these number of features. So what we'll do, I'll show you the box plot or the dist plot on the age feature, and I'll explain what the dist plot basically shows you. So what I can do, I can make one feature called age 1, and I will pick up the age column from the Titanic dataset, and I'll use drop NA function on this age 1. Now what does drop NA will do? It will remove all the null values that are present inside the age column, and it will give me a new feature age 1, which is essentially derived from the original age feature that we already had in the dataset. So this is done. Now what I can write, SNS dot dist plot, and inside the dist plot I want to give my new feature that I've made age 1, and I want, let's say, 30 bins, and the next thing I want to do is KDE will be equal to false, and I can write PLT dot show to see my dist plot. Okay, it is Titanic. Now I have the dist plot ready. So now what dist plot tells you, it gives you a basically a histogram. You can also try different features of histplot. You can plot lines on the top of this histogram, but it is giving me basically the distribution of the age feature that I have inside my dataset. So if you try to interpret from the histogram, the maximum number of people that I have in the dataset are from, let's say, 15 to 55, and the majority of the chunk goes around 25. So on the x-axis I'm having the age of the people, and on the y-axis I'm having the count of the people. So this is how you can to know the density of the data points that are present in your dataset. So again, his dist plot is also very important while you build some important machine learning models. So if you are able to interpret all these plots very carefully, then you can tweak your machine learning models in a certain way to get the better accuracy and better results from your ML model. Now third and the most important plot that we have is the reg plot. Now again, I'll take a new dataset to show the reg plot. So what I'll do, I'll make a new variable called data, and again SNS dot load underscore dataset, and this time I'll use, let's say, the MPG dataset. It will again take some time to load that data. It will load the MPG data that is already present in the cbin library into my new variable called data. So it's taking little too long to load the data. Let's wait for a few minutes and let's see what do we get. Okay, so the data is loaded. Now let's have a look what do we have inside the data. So the data contains these number of columns: MPG, cylinders, displacement, horsepower, acceleration, model year, and origin, etc, etc. Now my aim is to show you a rich plot, and I'll pick up two numeric features, acceleration and, let's say, MPG. So what I'll do, I'll write SNS dot reg plot. Inside this, on the x-axis I want MPG, and on the y-axis I want acceleration, and then the data set I want to use is data will be equal to data, and I can write plt dot show to show the plot. Now as you can see, I have a rich plot. So on the background I have a basically a scatter plot that shows the distribution of different data points and between acceleration and mpg. Now reg plot, what it will do, it will be very useful when we are working with linear regression models. So if you understand the a relationship between different features that are present in your entire data set, so it will be very easy for you to implement the best regression models, because the correlation between these two features, if the correlation is if you understand the correlation between different features, then the linear regression models will perform very nicely. Now what reg plot gives you is basically it gives you a best fit line and the scatter plot. So you can understand the distribution of the data between these two features, and you also have the best fit line that passes through all, covers all the data points and gives you a basically average or the mean value of these two features. So this is how you work with reg plot, box plot and disk plot in Seaborn. All these three plots are very important from the machine learning model point of view, so understand them very carefully. Now let's move to the next video. I hope you are clear with this concept. Thank you. Hello and welcome to the video on handling missing values. So in this video I'll teach you how to deal with the missing values in your data. So first of all, let us understand what is a missing value. Missing data is defined as the values or data that is not stored or not present for some variable in the given dataset. Below is a sample of missing data from the Titanic dataset. You can see the columns age and cabin have missing values. So this is the very famous Titanic dataset, and in the 8th section here in row number 6 we have one missing value, and in the cabin column row number 1, 3 and 5, 6 are having missing values. So this is what is called a missing value in a data set. So how is the missing value represented in the data set? So in the data set, blank shows the missing values, but when we usually load the data set in pandas, the missing values are represented by NaN. That is, so why is data missing from the data set? So there can be multiple reasons why certain values are missing from the data. So reasons for missing data from the data set affect the approach of handling missing data. So it's necessary why the data could be missing. So some of the reasons are listed below. Past data might get corrupted due to improper maintenance. Observations are not recorded for certain fields due to some reasons. There might be a failure in recording the values and due to the human error. The user has not provided the values intentionally. So these are some of the reasons for the missing values. Now why do we need to care about missing value? So let's say if the data set contains some missing value, we can directly work with the data set including the missing values. Like we should not treat them separately or try to fill them, or we should not try to know the reason why there is a missing value. But why do we really need to care about the missing value? So it is important to handle the missing values appropriately, because many machine learning algorithms fail if the dataset contains missing values. However, algorithms like k-nearest neighbors and naive Bayes support the missing values. So this is a very important point. Most of your machine learning algorithms will usually fail or may not provide good results if the dataset contains missing values. But some algorithms like k-nearest neighbors or naive Bayes may support the data with missing values. Now you may end up building a biased machine learning model which will lead to incorrect results if the missing values are not handled properly. So this is another reason, and missing data can lead to lack of precision in your statistical analysis. So these are some of the reasons why we care so much about the missing values in the dataset. Now some ways to deal with missing values in the dataset. So the first and the most famous way is that we replace the missing value with the mean. So this is the most common method of imputing missing values of numeric columns, because if we are saying that we'll replace it with the mean, then by definition the column should be numeric, because otherwise we won't be able to find out the mean. Now if there are outliers, then the mean will not be appropriated, because the mean will be deviated too much because of the outliers. So in such cases we need to treat the outliers and then we can use this method. So you can use the fill-NA method for imputing columns like loan amount and credit history with the mean of respective column values. So here this dataset has two different columns, loan amount and credit history, that contain the missing values. So what we are doing, we are replacing the missing values for the numerical columns like loan amount and credit history with the mean of that entire column. So train df of loan amount, train df of loan amount dot fill na to fill the na now, and we will calculate the mean and impute at the place of the missing value. Same thing is done for the credit history column. Now another important method is replacing it with the mode. So mode is most frequently occurring value. It is used in case of categorical features. So replacing with mean is used in case of numerical features, and replacing with mode is used in case of categorical features. Now you can use the fill na method for imputing the categorical columns like gender, married, self-employed. So gender will be a categorical column like male, female, male, female. Now married can be yes, no, and self-employed again can be yes or no. So these are all categorical values. So we'll use this code and this approach to fill the missing values with the mode of the entire column. So this was about replacing with mode. Now imputing missing values for categorical features. So there are two ways to impute missing values for categorical features. Impute the most frequent value that we saw. Now we can also use something called simple imputer. In this case, as this is a non-numeric column, we can't use mean or median, but we can use the most frequent value and constant. So impute the value missing, which treat it as a separate category. So when we were talking about replacing it with the mode, we were like, for if we take the example of the gender column, let's say the mode of that column is male. So male is the most frequently occurring value in that column. So in the previous approach, we'll simply impute the missing cell with male, the mode of the column. But here, by using the simple imputer, we can create a third category itself, missing, that will treat missing as the third category of that column. So the model will understand that this missing is a third category. So this can also be done. So I hope you're clear with the basics of why do we treat missing values separately and why it is important to deal with them and the basic concept. So let's move to the practical section and try to implement all this. So let me show you the practical implementation of how to treat the missing values. First of all, here I have one data frame in which I have stored the placement data. Now this data contains multiple columns like gender, percentage, section, degree, salary, status, specialization, etc, etc. Now if I write df.isNull.sum, I can see that the salary columns contain 67 null values. Here, as you can see, there are some NaN present in the salary column. All other columns do not have any missing values, but salary column has. So first of all, let me show you how to fill this or treat this kind of column without the help of simple imputer class in sklearn. So we'll simply use pandas, and what I have done, I have replaced the missing values in the salary column with the mode of the column. So if I don't count the missing values and generally find the mode, let's say 2,70,000 is the most frequently occurring salary of this column. So I'll simply replace all the missing values inside the salary column with 2,70,000. So how do we do that? So df.salary, and we'll store df.salary.fill na will fill na with the mode of this df.salary column, and this will be stored back into the df.salary column. Now once after treating this, if we write df.isNull.sum again, we can see that now we have 0 missing values in the salary column. So this is how you treat the missing values with mode. Again, if I show df.head, and see, it is replaced with the mode of this salary column. Now we do not see the NaN. So here, instead of NaN, we are having a filled value. Now let's learn about the simple imputer class in sklearn. So first I have to import from sklearn.impute, import simple imputer. Now I'm creating my sample data set. First of all, I'm making the instance or the object of the class. So simple imputer missing values, we have to fill np.nan wherever we find the nan, and strategy is mean. So we want to replace the values, the missing values, with the mean of that column. So strategy is mean, and we have to replace np.nan. So this, we have created one object of the simple imputer class. I'm intentionally making one sample data which with some null values. So 12 np.nan 34, 10 32 np.nan, np.nan 11 20. So this is the sample data that I have intentionally created with some nan values. Now if I print the original data, so 12 NaN 34 and NaN. So we can see we are having NaN in the data. Now imputer is equal to imputer dot fit, and will fit this on data. Once we are done this, and then we'll call the transform method, and once we are done with fit and transform method, and if I print the data one more time, then it has replaced the missing values in the data with the mean of the data. So this was about the simple imputer class of sklearn. I hope you are clear with both the approaches, and now you can treat and handle missing values very comfortably in your data science projects. Thank you. Let's move to. Hello and welcome to the video on feature encoding. So first of all, let us understand about different encoding techniques. So in many practical data science activities, the dataset will contain a lot of categorical variables. Now these variables are typically stored in text values, and since the machine learning models are completely based on mathematical equations, it would cause a problem when we keep categorical variable as it is. So many algorithms support categorical values without further manipulation, but in those cases it's still a topic of discussion whether it's to decide whether we want to encode or not. But a majority of machine learning models only work with numeric or mathematical numbers. So we have to encode those categorical variables into a mathematical or a numeric value, so that the machine learning model can understand that the importance of that particular feature. Now different encoding methodologies. So in nominal encoding, where the order of data does not matter. So in categorical variables, further we can divide them into nominal and ordinal. Nominal is basically where the order of data does not matter, and ordinal, as the name suggests, the order of data matters. So in nominal encoding, we have different kind of techniques like one hot encoding, one hot encoding with many categories, and mean encoding. When you're working with ordinal data, or where the order of the data is very important, so in ordinal encoding, the techniques are label encoding and target guided ordinal encoding. Now again, here you can understand this with the help of a visual representation. So categorical variables are divided into nominal and ordinal. Some example of nominal can be pen, pencil, eraser, or maybe let's say different categories of animals: cow, dog, cat, etc., etc. But ordinal, as the order suggests, excellent is better than good, and good is better than bad. Again, fantastic is better than okay, and okay is better than don't like. So here in these kind of categorical variables, the order matters. If I say something is good and something is excellent, so the thing that is excellent is much better than the thing that is good. So to deal with this kind of variables, we have to use the ordinal encoding techniques. Now first of all, let us understand one hot encoding. I'll also show the practical implementation of these encoding techniques once we are done with the theory presentation. So let's understand one hot encoding. So in this method, we map each category to a vector that contains 1 and 0, denoting the presence of the feature or not. So the number of vectors depends on the categories which we want to keep. For high cardinality features, this method produces a lot of columns that slow down the learning significantly. There is a bus between one hot encoding and dummy encoding, when to use one. They are much alike, except one hot encoding produces a number of columns equal to the number of categories, and dummy producing is one less. This should be ultimately handled by the modeler according to the validation process. Now let's understand one hot encoding with this practical example. So let's say in a data set we have one feature called city, and city contains different value: Roma, Madrid, Istanbul. So these are three different categories of city that we have inside the city column of the feature of the data set. Now if we perform the one hot encoding, so what we'll get: Istanbul and Madrid 0 0, and we will have one more column of Roma that will contain 1. Again, for the second column where the value is Madrid, we'll have 0 for Istanbul, 0 for Roma, and Madrid for 1. So instead of giving the textual input directly to the machine learning model, we encode those features into a 1010 kind of format. Now here we can also see this is drop one method. We just drop the third category because only 0 1 different combinations of 0 1 are sufficient to tell that machine learning model about three different categories. two combinations of 0 1 are sufficient to tell the machine learning model about three different categories. But we can also do something like this. We can add a third column for Roma and 0 0 1. 1 will be for Roma. Again, if we have Madrid, then 0 1 0. And if we have Istanbul, then 1 0 0. So these are the type of one hot encoding. Now let's understand label encoding with the example. So in this encoding, each category is assigned a value from 1 through n. Here n is the number of categories for that particular feature that we have in the dataset. So it may look like car, bus, truck 0, 1, 2. Now categories that have some ties or are close to each other, others lose some information after encoding. For example, here in this column we have different values like a, b and c. So for general understanding, we consider that a is superior to b and b is superior to c. So a will be ranked 1, c will be ranked 2 and b will be given the number 2. So simply we will encode the labels with 1, 2, 3. If we had a fourth category of d like a, b, c, d, different fourth value of d in this particular feature, then d will be given the number 4. So this is how label encoding works. Now I hope you're clear with the techniques that we discussed here in the presentation. Let's move to the practical section and try to implement them in Pandas. Thank you. Hello, and let us start with the practical implementation of feature encoding techniques in Pandas and machine learning. So the first technique that we're going to see is about one-hot encoding. I'll be showing you two techniques. One-hot encoding is used for the input features, or you call the independent features, and label encoding is also used for the target attribute, so or the features that you have in the y section, or the dependent feature, or that you are trying to predict. So this is the important difference. This is used for input features, this is used for the target variable. So remember this important point. Now let's first take one example for the one hot encoding. So let me import pandas as pd. Next I'll import one data frame or a CSV file, pd.read CSV, and I have airport.csv. Let me see what I have inside this data frame. So this has different features like ident, type, name, latitude, and so forth. So these are the different columns that we have inside this file. Let's take this type column. It is a categorical column and it has textual data inside that column. So let's try to encode this. First of all, let me write df of type dot value underscore counts. So this contains 5 different categories. So you have one type of large airport, closed heliport, medium airport, and small airport. So these are different type of values that are present inside the type column of the dataset. To perform one hot encoding using pandas, we have this very important function called get underscore dummies. So how do we perform that? I'll show you. So we can write pd dot get underscore dummies, and here I'll give the data frame that I want to use. So I want to use this df that contains airport.csv, and the columns that I want to perform the one hot encoding is the type column. So if I run this cell, then I'll get this kind of output. So as of here, you cannot see the type column, but here if you scroll down to the end, then now you have each separate feature for all the categories that we had inside the type column. So you have one type, type closed, type underscore heliport, large airport, medium airport, and small airport. So wherever the type was large airport, we have 1, and rest all columns will have 0. So this is how you perform a one hot encoding using pandas. So for example, here in this row, you have a small airport that value is 1 and rest of the values are 0. So this was about one hot encoding using pandas. Now let's take one example of label encoding. So let me import a new dataset, so df1, and let me show you label encoding on a very famous dataset, that is iris. So pd.read underscore csv, and here I'm going to use iris.csv. So let's see what do we have inside this dataset. So df1.head, as I told you, label encoding is used on the target variable. So here, while we are working with this dataset, By using the sepal length, sepal width, petal length and petal width, we are trying to predict the class of the flower or the species of the flower. So Iris setosa, Iris virginica, and so on and so on. So here we want to encode this feature, because again the machine learning model cannot understand the textual data, so we want to encode the target feature. So we will use label encoder. So first of all, let me import from sklearn dot pre processing import label encoder. So this label encoder that we are going to use, now I'll make one instance. So le label encoder will be label encoder. Now finally what I'm going to do, I'll encode the values of a species and again store them into the same data set. So I can write df1 species, and this will be equal to le dot fit underscore transform, and inside this again I'm going to encode this feature only. So I will give this one, and now if I check what I have inside my df1, so as you can see now I have encoded all the species. So Iris setosa is encoded with 0. If I want to see something else, then I can write df1.tail. So the other species are maybe 1 and 2. So these are the different values of different species that we have encoded with the help of label encoder in sklearn. So I hope you are very clear with the practical implementation of feature encoding and different techniques that I showed you, and also the concept of feature encoding and why do we use it in machine learning. Hello and welcome to the video on feature scaling. In this video, I'll tell you about a very important technique in machine learning that will be useful in your data analysis and ML journey. So, feature scaling is a technique to standardize the independent features present in the data inside a fixed range. This step is performed during the data pre-processing part. The most common feature scaling techniques are normalization and standardization. So first of all, before moving into the technical details of feature scaling or standardization or normalization, I'll try to explain why do we need feature scaling with the help of a practical scenario. Let's say you're trying to build a machine learning model, and the features that are used as an input for that model are age of that person and the salary of the person. Now, if you try to compare the absolute magnitude of the numbers, the age will be somewhere around the range of 25, 35, 40, 50, or max to max 80, 90, or 100. But the range or the absolute magnitude of the salary numbers will be 100,000, 200,000, 90,000. And so the difference between the absolute numbers of different features will create an impact on the decision making of the machine learning model. And so to avoid that, we are using feature scaling. Now let's understand this with the help of this beautiful picture. So here on the left side you have your original data, and it is we haven't done any scaling or normalization on that. Now if we apply normalization on the original data, what normalization will do, it will bring all the data points in a certain range of 0 to 1, and if standardization will bring them from -1 to +1. So this is how feature scaling works. Now let's start the first technique of the feature scaling, the min max scaler, right? So before that, let's create our sample data set. So here I have made one sample data set. In this data set, I am using two features as I told you in the example. I'm having a list of fruits: orange, apple, banana, and grapes, and I am having the weight of that fruit and price of that fruit. So if you have a very close look at the data, the values for the weight of the fruit is higher compared to the price of the fruit. So this will create an imbalance, or this will impact the decision making of the model based on the values of different features. And so we are learning how to avoid that with the help of this min max scaler. So first of all, let us understand the formula of min max scaler. The new data point for the min max scaler will be, if it will take that particular data point and it will subtract the minimum value for that and will divide that by the difference of the maximum and the minimum. For example, if I want to scale this feature, so what this will do, x will be 15 and minimum of x means, so minimum of the entire column, so minimum will be 10, So 15 minus 10, and we'll divide it by maximum minus minimum. So the maximum value for the column is 18, and if we subtract the minimum 10, so it will be in the denominator we'll have 8. 18 minus 10, 8, and on the numerator we'll have 15 minus 10, that is 5. So this is how min-max scaler works. Transform features by scaling each feature into a given range. This estimator scales and translates each feature individually such that it is in the given range on the training set. Example, between 0 and 1. Now this scaler shrinks the data within the range of -1 to 1 if there are negative values. So we can set the range like 0 to 1, 0 to 5, or -1 to 1. The scaler responds well if the standard deviation of the data is very small. So this is very important point that you can remember. This type of scaler will work very good when the standard deviation of data is very small and when the distribution is not Gaussian. And another most important thing is that this scaler is sensitive to outliers. And how do we implement min-max scaler in the sklearn? So from sklearn.preprocessing we'll import min-max scaler, and I'll make this object of a scalar object of the min-max scaler, and then I have my data frame, the fruit data set that I already showed you, weight, price, and of the fruits. And then here I'm plotting the values of the data set before and after scaling. So if you have a close look on this plot, these three are the original data points, these four are the original data points before scaling, and as you can see the difference between their values that it is creating without scaling, before scaling. All the star marks are the data points before scaling, and once we perform the scaling, then the data is scaled to proper units. So this is how min-max scaler works. Now let's move to the next type of scaler that we'll see, that is the standard scaler. So the formula for standard scaler is the data point minus mean divided by the standard deviation of the column or the feature that we're trying to scale. So the standard scaler assumes that the data is normally distributed. This is an important assumption that we should keep in our mind. This scaler assumes that the data is normally distributed and within each feature, and scales them such that the distribution is centered around 0 and with a standard deviation of 1. So this is a very important interview question. They'll ask you that what is the distribution and the standard deviation of the new data points that you get after performing the standard scaling. So the distribution is centered around 0 and the standard deviation will be 1. So centering and scaling happen independently on each feature by computing the relevant statistics on the samples in the training set. If data is not normally distributed, this is not the best scaler to use. So we can check whether the data is normally distributed or not. If the data is normally distributed, then we can go ahead and work with this scaler. Now again, we will use from sklearn.preprocessing import standard scaler. For we also had the min-max scaler, and now we have the standard scaler. Both are from sklearn.preprocessing. Again, we'll create one scalar object for standard scaler. Same data set, fruit, prices, and weight. Now here I am plotting another plot. As you can see, this time these are the original data points with the star marks, and now here I have the standard scaled values. So the mean of this data will be centered around 0 and the standard deviation of the scaled data from the standard scaler will be 1. Now another very important question is that should we use or should we perform feature scaling on each and every machine learning project that we are doing? The answer is no. Algorithms like KNN or maybe some regression or maybe a clustering algorithm, if you're working with them, and one more thing, if you're working with neural networks, then scaling should be done each and every time. But if you're working with algorithms like random forest, decision tree, the tree based algorithms that don't have the weightage of individual numeric values of different features, then standard scaling is not required. I'll repeat this important point one more time. If you're working with some tree based algorithms like random forest, gradient boost, or decision trees, then scaling is not required. But if you're working with algorithms like KNN, neural networks, and maybe some clustering algorithms, then feature scaling should be done in each and every machine learning project. So I hope you're clear with this concept of feature scaling. Now let's move to the next video. Hello and welcome to the video on machine learning introduction. In this video, I'll introduce you to the basics of machine learning. We'll learn about different types of machine learning, and I'll try to give you some roadmap of how we are going to cover machine learning in the next few videos of the course. So let us start. First of all, let us formally define what is machine learning. So, machine learning is said as a subset of artificial intelligence that is mainly concerned with the development of algorithms which allow a computer to learn from the data and past experiences on their own. The term machine learning was first introduced by Arthur Samuel in 1959. In a summarized way, machine learning can be simply said that it enables a machine to automatically learn from data, improve from past experiences, and predict things without being explicitly programmed. So, this is how you can define machine learning formally. Now, let us try to understand with the help of this picture. So, a human usually can learn automatically from his or her own experiences. Here the machine also says the same thing. I can also learn from the past data with the help of machine learning. So up till now, whatever we have covered in the data science or data cleaning portion, so we were having a CSV data set. Now we were doing all the data pre-processing and data cleaning steps on that data set. Now the cleaned data will be given as the input to a machine learning model, and all the analysis and predictions will be done by the machine learning model. So this is the life cycle. This is the entire life cycle of a data science or a ML project. Now, with the help of some sample historical data, which is known as the training data, machine learning algorithms build a mathematical model that helps in making predictions or decisions without being explicitly programmed. Machine learning brings computer science and statistics together for creating predictive models. Machine learning constructs or uses the algorithms that learn from historical data. The more information we provide, the performance will be better. A machine has the ability to learn if it can improve its performance by gaining more data. So, we train the machine learning model on some sample training data, that is the historical data that we have. Now, once the model is trained on the training data, we can use new data sets on the same model to predict the output. So, this is the life cycle. So, input past data will be given as training to the machine learning algorithm. This machine learning algorithm will learn and extract patterns from that data, and it will, based on the patterns extracted and the learnings from the training data, it will build some logical models or patterns. The ML algorithm will build that. Now, once we have a ready trained model, the ML model, now what we'll do, we will give new data to that model and then we'll predict the output. I'll tell you a real life case study of the machine learning process. So let's say we are having 5 different images, or we are having some different images, and the images can be of an apple or an orange. So what we do, we have a, let's say, a machine learning model ABC. Now we'll give or we'll train the machine learning model ABC on hundreds or let's say 1000 of images. The 1000 images that we're giving as training sample to the model will have the images of both orange and apple. So let's say the machine learning model will try to derive features of apple and oranges. Let's say from an image of an orange, the model derives some features like it is round in shape and it is of orange color. And from the image of apple, the machine learning model extracts the feature like it is of red or green color. So based on the learnings that the model has derived from the training data set, the sample of 1000 images that we gave to the model, it will store all those learnings and create a specific pattern inside it. And if you give a new image to the same trained model, now the model will be able to classify it between apple and orange. So this is how the life cycle of a ML project works. Now, after saying that, let us discuss the different types of machine learning that we are going to study. So first of all, we have the supervised machine learning, then we have unsupervised machine learning, and then we have the reinforcement learning. For the scope of this course, we are going to cover these two in detail. So supervised and unsupervised. Supervised machine learning can be further be classified into classification and regression problems, and unsupervised learning can be also known as the clustering or segmentation problems. So in regression, basically we try to predict the numerical value. Let's say you are having the features of you are having different attributes about student, his IQ, his age, his CGPA, and you are trying to predict the salary of the student. So that is a numerical value that you are trying to predict. So that will fall under supervised learning, and even in supervised learning we can call it a regression problem. And the apple orange example that I gave you can be called as the classification problem. So we are trying to classify the images into apple or orange. Now moving on to unsupervised learning. In unsupervised learning, a very good example can be clustering algorithms. For example, a retail store wants to cluster its customer into different groups based on the credit score, salary, income, spending habits, gender, etc. etc. So it will create different clusters of the customer. So in cluster 1, let's say we are having those customers, they have a very high tendency to spend, so the store will pitch more high-end products to that particular customer. And let's say in cluster 3 we are having different kind of we are having some kind of customers that don't spend very much, so the store will offer more discount or something like that to the customers that are present in cluster 3. So these are the types of machine learning that we are going to cover in detail in the next few videos. So I hope you are very clear with the basics and introduction of the machine learning that I gave you in this video. Now let's move to the next video. Thank you. Hello and welcome to the video on supervised machine learning. In this video I'll teach you the basics of supervised machine learning and how it works. So supervised learning is a type of machine learning in which machines are trained using the labeled training data, and on the basis of that data machines predict the output. So the labeled data means some input is already tagged with the correct output. In supervised learning, the training data provided to the machines work as a supervisor that teaches the machine to predict the output correctly. That's why the name supervised learning comes. It applies the same concept as a student learns in the supervision of a teacher. Now, supervised learning is a process of providing input data as well as correct output data to the machine learning model. The aim of a supervised algorithm is to find a mapping function to map the input variable X with the output variable Y. Some real-world examples of the supervised machine learning can be risk assessment, image classification, fraud detection, spam, mail filtering, etc. and etc. So I'll make you understand in a better way with the help of this diagram. So this is the entire life cycle of a supervised machine learning project. So here is your machine learning model. Now we want to train this model with the help of some labeled data. Let's say we are having a data set that contains images of 3 different type of shapes. The first one is hexagon, the second is triangle, and the third is square. So what will we do? Let's say this data set has 100 entries. So we will use 70 entries and each of them will be labeled. So all the 70 entries, all the 70 rows that will be given to the input to the machine learning model for training will be labeled. So this will be known as hexagon, this is square, this is triangle. So this all 70 rows will be given to the model for training. Then once the model is trained on the training data, then what we'll do, the test data, that was the remaining 30%, or in this case the remaining 30 rows of the data set, then we'll give those 30 rows to the model for prediction. Now these 30 rows will not have the labeled attached to the picture. So this in the test data only this picture will be given as the input to the model, and based on the patterns that the model has extracted from this training data, it will predict that this is the picture of a hexagon, this is a square, and this is a triangle. So if I want to explain you with the help of this picture, so here we are giving the labeled data for model training. These are the labels. Now once the model is trained, we want to predict the output on the test data. Now if you have a look on this data set very carefully, we don't have labeled data. This is just an image of a square and a triangle. We are not labeling them. So the model will correctly predict that it is square and it is triangle based on the patterns that it has derived from this training data. So this is how supervised machine learning works. Now again, supervised machine learning can be further classified into 2 subcategory of problems. So in supervised machine learning, mostly we'll be dealing with regression type of problems and classification type of problems. So the problems in which we want to predict a certain numerical value. Let's say we are having the IQ of a student, we are having the CGPA of the students, we are having the high school mark sheet of the student, and based on these numbers we want to predict the next year CGPA of the student. So this, as we are trying to predict a particular number, that is the CGPA, so in such numerical case we call it a regression problem. And the classification problem will be like, let's say you are having the IQ of the student, you are having the CGP of the student, you are having the mark sheet of the student. Now you want to predict that whether the student will get a job in campus placement or not. So getting a job or not. So there are two categories that in which we want to classify the student. So this is how the classification problem works in supervised machine learning. So I hope you are very clear with supervised machine learning. This is the entire life cycle of the supervised machine learning, and these are the two different types of problems that we are going to deal in supervised machine learning. So let's move to the next video. Thank you. Hello and welcome to the video on unsupervised machine learning. In this video, I'll tell you about the basics of unsupervised machine learning. So let us start. First of all, what is unsupervised machine learning? As the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training dataset. Instead, models itself find the hidden patterns and insights from the given data. It can be compared to learning which takes place in human brain while learning new things. So formally, unsupervised learning can be defined as that it is a type of machine learning in which models are trained using unlabeled dataset and are allowed to act on that data without any supervision. Now, unsupervised learning cannot be directly applied to a regression or a classification problem, unlike we saw in the supervised ML. But we have the input data, and no corresponding output data. So the goal of unsupervised learning is to find the underlying structure of the dataset, group that data according to the similarities, and represent that dataset in a compressed format. Now, have a look at this example, and the concept of unsupervised learning will be very clear to you. So now here you have this model, and we won't train the model using the training dataset that we discussed in the supervised learning, that we keep 70% or let's say 80% data for training. We use that data to train the model, and then we test the model on the remaining 20% of the data. That we don't follow here. We'll give the entire raw input data to the model. Without explicitly being trained, the model will extract certain patterns from these unlabeled data points, and it will automatically categorize these data points into different categories, or the segmentation it will perform. So here, based on the features extracted from the data, the model automatically clustered the images into dogs and cats. So this is also known as the clustering problem. Will cluster similar type of images together. So in cluster 1 we are having all the images that have dogs, and in cluster 2 we are having all the images that have cats. So here we are not performing the label data part or the training data set that we used to do in the classification algorithm, or the supervised machine learning algorithms. Now, unsupervised learning can be further be divided into two more sub problems. The first one is what we call the clustering problem, the example that we saw in the previous slide. This is a clustering problem. The second problem that we solve is the association problem, or a very famous example for this association is the market basket analysis. All these two problems we'll see in detail in the next few videos, but for the part of this video you should be very clear with the difference of supervised and unsupervised machine learning and the entire life cycle of a unsupervised machine learning project. So I hope you're very clear with all the concepts that were discussed in this video. Now let's move to the next video. Thank you. Hello and welcome to the video on train test split in machine learning. So usually in supervised machine learning techniques, what we do, let's say our dataset contains 100 rows. So we'll train the model with 80% or 70% or let's say 75% of the data. So we'll split the dataset into two different parts. First will be the training part and second will be the testing part. So the model will learn or extract patterns, or you can simply call, will train the model with the training portion of the data, that will be around 70 or 80% of the data. And then once the model is trained, we'll validate or test the model on the remaining 20% of the data that is still very new for the model. So after training the model, we'll give the unknown test data that we separated the 20% of the data after for validation purpose. So this is the use of train test split. As you can see, we have initially prepared our data, then we split the data into training part and testing part. The model will be trained, or the model will learn the patterns on training data, and then once it is trained, we'll give the test data, we'll evaluate the model and check whether what are the changes that need to be done. So train test split is a model validation procedure that allows you to simulate how a model would perform on new unseen data. Here is how the procedure works. So this is the full data set. Now these are all the features of the data set, and this is the target variable. We train test split, and this will consist of random sampling into training and testing sets. So this training portion will be used for training the model, and then once the model is trained, we'll give this test section and evaluate the model how it's performing. So the syntax from sklearn to perform the train test split operation is, from sklearn.model_selection we have to import the train test split, and then this is automatically inbuilt in the sklearn. So we have to write xtrain, xtest, ytrain and ytest. So xtrain and ytrain are the features and target of the training set, and xtest and ytest are the features and target of the test set. So we have to compulsorily maintain this order. First we have to write xtrain, then xtest, ytrain and ytest, then train underscore test underscore split, we have to call this, and then we have to pass the dependent and independent features. So our x will contain the dependent or the independent features, and y will be the target or the dependent features. Now random state, and then test train size. So here we are using train size is equal to 0.75. That is 75% of data will be used as training, and remaining 25% will be used for testing. If we don't want to specify train size but we have to give the test size, then instead of train size we can write test underscore size, that will be equal to 0.25. So you can use train size or test size, depends upon you. So this was a little short concept that we are going to use in most of our supervised machine learning tutorials. Like if we study any algorithm like random forest decision tree, regression, etc., etc. So train test split is a compulsory step that will perform in the machine learning life cycle. So I hope you're clear with this concept. Now let's move to the next video. Thank you. Hello and welcome to the video on regression analysis. In this video, I'll teach you the basics of regression, and I'll also tell you about some important terms that we use very oftenly in the world of regression in machine learning. So regression analysis in machine learning. Regression analysis is a statistical method to model the relationship between a dependent or a target variable and an independent or the predictor variables with one or more independent variable. More specifically, regression analysis helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. It predicts continuous real values such as temperature, age, salary, price, and etc. So whenever we are talking about regression, we will be talking about continuous values like temperature, salary, etc., etc. Now let us understand with the help of this example. Suppose there is a marketing company who does various advertisements every year and gets sales on that. The below list shows the advertisement made by the company in the last 5 years and the corresponding sales. So here we have 5 advertisements. So advertisement 1, $90 and sale was $1,000. Advertisement 2 is $120 and the sale is $1,300, and so on. Now the company wants to know to do the advertisement of $200 in the year 2019. In this year, the company wants to do the advertisement of with the budget of $200 and wants to know the prediction about the sales of this year. So this we want to find. So to solve such type of prediction problems in machine learning, we use this regression analysis. So what we'll do, we'll train the model based on this entire data, and finally this data will be given as the input to the model at the time of prediction. So based on the patterns extracted from these data points during the training phase, the model will predict the sale value for this particular entry. I hope regression is very clear. Now some important terminologies related to regression analysis. Before deep diving into different regression algorithms that we're going to study in the course, you should be very clear with all these terminologies. So first one is a dependent variable. The main factor in regression analysis which we want to predict or understand is called a dependent variable or the target variable. So for this example, the sale will be a dependent or a target variable. Independent variable, the factors which affect the dependent variables on which are used to predict the values of dependent variable are called independent variables or the predicted. So the value of sale depends on the budget of the advertisement. So this will be the independent variable. The value of sale will depend on this one. So this will be dependent and this will be independent variable, or this is also known as the predictor. Now outliers. Outlier is an observation which contains either very low value or very high value in comparison to other observed values. Let's say in this example we have a entry with a budget of $1,000 and sales of only $20. So that will be considered as the outlier because the value is either very low or very high compared to the other observed values. So the point should be noted that an outlier may hamper the result, so outliers should be avoided. Now multicollinearity. If the independent variables are not highly correlated with each other than other variables, then such condition is called multicollinearity. It should be not present in the dataset because it creates a problem while ranking the most affecting variable. So due to this, you won't be able to find the most affecting variable or the variable that affects the target variable the most. Now underfitting and overfitting. If our algorithm works very well on the training dataset but does not perform well on the test, so when you're training the model, it is working very well, but at the time of testing you are not getting the desired output, then such problem is called overfitting. And if our algorithm does not perform well even during the training dataset, and such problem is called underfitting. So these were some important terms. Now these are some of the important regression algorithms that we're going to see in the course: linear regression, SVM, decision tree, random forest. So these are some types of regression algorithms. So I hope you are very clear with the basics of regression. Now let me introduce you to a concept of linear regression. So linear regression is a statistical regression method that is used for predictive analysis. It is one of the very simple and easy algorithm which works on regression and shows the relationship between continuous variables. So linear regression shows the linear relationship between independent variable x and dependent variable y-axis. So we will plot the independent variable on our x-axis and dependent variable will be on the y-axis, and we'll try to establish a linear relationship. Hence it is called a linear regression. If there is only one input variable x, then such linear regression is called simple linear regression. And if there are more than one input variables, then such regression will be called multilinear regression. So when we have more than one features on which the value of the target variable depends, then it is called multilinear regression. So the relationship between variables in the linear regression can be explained using the below image, and here we are predicting the salary of an employee based on the year of experience. So with the help of this image, the linear regression will be very clear to you. So on the y-axis we are trying to predict the salary, and we are trying to predict the salary based on the experience of that particular employee. So these are all the data points. So the employee with the experience of 2 years is having a salary of around 35,000. The employee with an experience of, let's say, 5.5 years is having the salary of about 50,000. So based on the trend that we are identifying from the given data points, we will try to establish a linear relationship. And let's say a new employee comes to us with the experience of around 9 years. So we'll plot that employee in the experience of around 9 years over here, and we'll say the salary will be around $110,000. So this is how linear regression works. We are basically trying to draw a simple equation of a straight line. Y is equals to ax plus b. So y will be a dependent or the target variable on the y-axis, and x will be our independent variables. A and b are basically the coefficients. This is very similar to the equation y is equals to mx plus c that you studied in the coordinate geometry in your high school mathematics. So if you are clear with that concept, linear regression will be very easy for you. So I hope you are clear with all the concepts that are discussed in this video. Thank you. Now let's move to the next video. And welcome to the video on linear regression. In this video, I'll tell you about the linear regression algorithm in machine learning. And after the presentation and the theory portion is discussed, I'll also show you the practical implementation of linear regression algorithm with the help of sklearn in Python. So Linear regression is one of the easiest and the most popular machine learning algorithm. It is a statistical method that is used for predictive analysis. Linear regression makes prediction for continuous or numerical values such as sales, salary, age, product, price, etc. etc. Now, linear regression algorithm shows a linear relationship. It tries to establish a linear relationship between a dependent variable y with one or more independent variables x. Now, that's why, because it is trying to establish a linear relationship between the target and dependent features, that's why we call it a linear regression algorithm. Linear regression shows linear relationship, which means to find how the value of dependent variable is changing according to the change in the value of independent variable. The linear regression model shows or provides a sloped straight line representing the relationship between the variables. Consider these images. Now, here on the y-axis we always have the dependent variable or the value that we are trying to predict, and on the x-axis we have the independent variables. So these are all the data points, and this is the basically the line of linear regression that we are trying to plot. So if in case in future we get a new data point somewhere over here, then we can simply put or place it with the help of the line of linear regression and tell the value of the dependent variable or predict the output based on the independent features that we are getting for a new data point. Now let's understand positive linear relationship. If the dependent variable increases on the y-axis and the independent variable increases on the x-axis, then such a relationship is termed as positive linear relationship. So this is the image for positive line of linear regression. So the equation for this line can be given as y is equals to a0 plus a1x. Now all the linear equations for a straight line that we learned in the high school can be derived from that equation, like y is equals to mx plus c. So m is the slope and c is the intercept. So here if we try to map that y is equals to mx plus c with this equation given over here, so a1 will be mapped to m and this a0 will be mapped to c. So the equation of the line becomes y is equals to mx plus c or y is equals to a0 plus a1x. Now this clearly by seeing we can say that this is a positive slope of the line. Similarly, we can also have the negative slope here. So the equation, because this is a negative slope or negative line of regression, will have a negative value in the equation. Why do we get such negative line of regression? Because the dependent variable decreases on y-axis and the independent variable increases on the x-axis. So the value of x-axis increases but the value of y-axis keeps going down. That's why we get a negative linear relationship. Now let's move to the Jupyter notebook and try to implement the linear regression algorithm in sklearn. So let us start with the practical implementation of linear regression in Python. First of all, I'll import all the required libraries. So let me import NumPy as NP, import pandas as PD, and import. I'll also show you the visualization for linear regression. So for that I need matplotlib dot pyplot as plt. So these are all the required libraries. Now let me get the dataset into a pandas data frame. So pd dot read underscore csv, and I'll be using a salary data dot csv. And if I want to show you how the dataset looks like, so it says salary. Okay, I have made a spelling mistake. Now we have the salary data. So let us look how our dataset looks like. So here this is the dataset. It has two columns, years of experience and salary. So the salary will be our target variable and years of experience will be our x fee or the independent feature. So based on the years of experience we can decide the salary of that employee. Now so let me split x and y axis. So on the x, the independent feature will use dataset dot ilog. Here what I'm going to do, I just want to select all the rows and only the values of years of experience, and y will be my data set dot ilog. And here what I want to do is Okay, I forgot to put a comma over here. Now here what I want to do is dot values. So now I have my x and also here I have my y. So these are x and y for our machine learning model. Now what I'm going to do next, I'm going to split my dataset into train and test. So we'll use 70 or let's say 80% of the data for training, and then we'll evaluate or test the model on the remaining 20% of the data. So for that I need to include from sklearn dot model underscore selection import train test split, and then I want to make x train, then I have x test, then y train and y test, and I will call this train test split, and I want to make split on x and y, and the test size I want to use only 20% of the data for test, and then I want to use the 80% of data for training. So this will import the train test split feature that sklearn gives us, and then will separate out the data from the entire data set. That's it. That is, we will keep 20% of the data for testing, and then we'll have the 80% of the data for training. So after doing all this, finally we'll import the linear regression model. So from sklearn dot linear model import linear regression. It will take some time to import the model, and now what I'm going to do, I'm going to make the instance of the model, let's say the regression object, and this will be of linear regression. So this is the regression object, and now I'll use the fit method. So we'll to train the model on the training dataset, we use the fit model, and we want to train it on x train and y train. So now we have a ready-made instance of the model. Now let's check the prediction of the test. So y underscore pred will be equal to ridge dot predict. So this is the predict method that we are going to use, and here I'll write x test, and x pred will be equal to ridge dot predict, and here I have the x train. So these are the predictions. Now let's visualize all this. So for that I need to use matplotlib. So plt dot scatter, and here what I'm going to do, I'm going to plot x train and y train, and let me plot this into green color. Now this will be the scatter plot. So these will be the data points, the training data points that we had in the training set. Now I want to also plot a line, the regression fit line from the x train and y train. So x train, and I have x pred, and here the color of the line I want is red, and then plt dot show. So if I run this, now here I am having the years of experience on x-axis and the salary on the y-axis, and this is for the training dataset. So let me also print something over here. So print, this is for training set. For training set we have this plot. Now let's also make the same plot for the test, that what we got from our linear regression output. So what I'll do, again I'll make a plt dot scatter. Inside the scatter plot, this time I'll have x test, and then I have the y test, and color will be let's plot the data points in blue. Plt dot plot. Now here I have x train and x spread, and again color, the line I want is red, and plt dot show, and this is for testing dataset. So test set. So this is how our linear model is working. We are actually getting a very good fit line that is able to predict the linear relationship between the number of years of experience and salary of the employee. So I hope you are very clear with the implementation of linear regression in Python. Now let's move to the next video. Thank you. Hello and welcome to the video on logistic regression. Logistic regression is one of the most popular classification algorithm, and in this video I'll teach you the math behind it and also show the practical implementation in SQL and Python. So let us start. Logistic regression is one of the most popular machine learning algorithms which comes under supervised learning technique. Now it is used for predicting the categorical dependent variable using a given set of independent variables. This statement is also true for other classification algorithms. Now logistic regression predicts the output of categorical dependent variable. Therefore, the outcome must be a categorical or a discrete value. It can either be a yes or no, or in mathematical terms we can say 0 or 1 or true or false, etc. But instead giving the exact 0 or 1, it gives the probabilistic value that lies between the range of 0 and 1. So this is the key point for logistic regression. Remember the statement and logistic regression will be very easy for you to understand. So logistic regression is much similar to the linear regression, except that how they are used. Linear regression is used for solving regression problems, while logistic regression is used for solving the classification problems. A lot of students are confused in the name of logistic regression. By the name, they think that it will be a regression algorithm, but actually logistic regression is a classification algorithm. So remember this point. Now, in logistic regression, instead of fitting a line that we used to do in the linear regression, that was y is equals to mx plus c, we fit an S-shaped logistic function which predicts two maximum values. Either it will be 0 or 1 on the maximum side. The curve from the logistic function indicates the likelihood of something, such as whether the cells are cancerous or not, mouse is obese or not, and based on its weight, etc. So logistic regression is a significant machine learning algorithm because it has ability to provide the probabilities and classify the new data using continuous and discrete data sets. Logistic regression can be used to classify the observation using different types of data and can easily determine the most effective variables used for classification. So let us understand logistic regression with the help of this image. So here we are setting the threshold value on 0.5. So anything or the probability that logistic regression gives, let's say it predicts y is equals to 0.8. As 0.8 is above the threshold value of 0.5, so we'll consider it 1. And for example, if logistic regression predicts that y is equals to 0.3 and based on a threshold value it is less than 0.5, so we'll predict it as 0. So this is how logistic regression works with the help of this S curve. So you can generate that S curve with the help of this logistic or sigmoid function. It is just another mathematical function and it has a curve like the S shape that we already saw. So the sigmoid function is a mathematical function used to map the predicted values to the probabilities. Now it maps any real value into another value within the range of 0 and 1. The value of logistic regression must be 0 and 1, which cannot go beyond this limit. So it forms a curve like S form. The S form curve is sigmoid function or the logistic regression function. In logistic regression, we use the concept of threshold value, which defines the probability of either 0 or 1, such as values above the threshold value tends to be 1 and values below the threshold tends to be 0. This we already discussed. Now, these are some of the mathematical equations that are important for logistic regression. So the logistic regression equation can be obtained from linear regression equation. The mathematical steps to get logistic regression equations are given below. So we know the equation of a straight line can be written as y is equals to b0 plus b1x plus b2x2 plus b2x3 and so on and so on. In logistic regression, y can be 0 and 1 only. So for this, let's divide the above equation by 1 upon 1 minus y. So y upon 1 minus y, 0 for y equals to 0 and infinity for y equals to 1. If you divide anything by 0, it becomes infinity. And if you, so we need the range between minus infinity to plus infinity and take any logarithm, then take the logarithm of the equation and it will become log of 1 upon y upon 1 minus y is equals to b0 plus b1 x1 plus b2 x2. So this is how you derive the equation of logistic regression. Now enough of the mathematics. Now let's move to the Jupyter Notebook and try to implement the logistic regression algorithm in Python. So let us start with the practical implementation of logistic regression. I have imported pandas and numpy. Now let me create a data frame. So let's name it df, and we have pd.read CSV, and the data set that I'm going to use is user data.csv and df.head. Let us see what we have in the data. So these are the columns that we have. First is user ID. This we are not going to use. So gender, age, estimated salary, and purchased. Now gender tells about the is a feature of the customer, age and estimated salary, and purchased tells that whether the customer has purchased that item or not. So if we have the value of purchased as 0, then probably the customer has not purchased that item, and if we have purchased is equal to 1, then the customer, he or she, has purchased that item. Now we already have a good idea about all the features that we have in the dataset. Now let's separate the x and y, or the dependent or the independent features. So df dot iloc, and here what I'm going to do, so 2 comma 3, and then a closed bracket dot values. So this will be our x. We'll do the same for y. So df.iloc, let me copy this and I'll paste it over here, and I only want 4, or the purchased or not purchased. So this will be our y. So let me see what do we have in x, and y is the 0 and 1. Now let's train and test. Let's split the dataset into train and test. So from sklearn.model underscore selection import train test split. Now I'll make x train, then I have x test, then I have y train, and I have y test, and this is equal to our x and y that we already made. So x, y, and test size, let's keep it 20% of the data for testing. Okay, so this we are having an error. Okay, I have to write train test and split. So now we have x train, x test, and y train, y test. Now let's perform scaling. So from sklearn dot pre-processing import standard scaler. Now let me create the instance for the scaler. So standard scaler for x, and this will be an object of standard scaler. Now firstly I'll fit transform on x train, and again I'll store it back into x train. So st underscore x dot fit underscore transform, and this is again x train, then x test will be st underscore x dot transform and x test. So now we are done. Now let's import the logistic regression model that we are going to use. So from sklearn dot linear underscore model, we will import logistic regression, and I'll create one classifier object. So CLF will be equal to logistic regression of, and then I'll fit or train this model on x train, on y train. So let me give the training sets x train and y underscore train. So now we have the trained model ready. Let me predict the results and store it into ypred. So CLF dot predict, and here I'll use X test. So let me see what do we have in ypred. So these are all the predictions that the model has made. Now let's test the accuracy of the dataset with the help of a confusion matrix. So from sklearn dot matrix import confusion underscore matrix, and I'll plot the confusion matrix. So confusion underscore matrix, and this is for ypred and y test. So let me see what do we have in CM. So what we are getting is the confusion matrix. As you can see, we have lot of elements present in the diagonal part of the confusion matrix, hence the accuracy is on slightly on the medium to high side. So hence we can say that logistic regression is a decent classification model on this dataset. Now let's move to the next video if you are clear with the concept. So thank you for watching. Hello and welcome to the video on k-nearest neighbors. In this video, I'll give you the basic understanding of k-nearest neighbors algorithm in machine learning, and will also show the practical implementation in a Jupyter notebook. So let us start. K-nearest neighbors is one of the simplest machine learning algorithms, and it is based on supervised learning technique. Now KNN algorithm assumes similarity between new test data case that we are going to evaluate based on the trained algorithm and available cases, and it will put the new case into the category that is most similar with the available cases. So KNN algorithm stores all the available data and classifies a new data point based on the similarity. This means when new data appears, then it can be easily classified into a well-suited category by using KNN algorithm. So KNN algorithm can be used for regression as well as classification, but mostly it is used in classification problems. So I'll also show you one classification example using KNN when we move to the practical section. So KNN is a non-parametric algorithm, which means it does not make any assumption on the underlying data. Like you don't have to assume that the data is in the normal form or not. So you don't have to take any assumptions. That is the one important benefit of KNN. It is also called a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the dataset, and at the time of classification, it performs an action on the dataset. KNN algorithm at the training phase just stores the dataset. When it gets new data, it classifies the data into different category. Now let's take one example. So suppose we have an image of a creature that looks similar to the cat and dog, but we want to know whether it's a cat or a dog. So for this identification, we can use the KNN algorithm as it works on a similarity measure. Our KNN model will find the similar features on the new dataset to the cats and dogs. Based on the most similar features, it will put either cat or dog category. So again, this is a classification problem. We have to classify the new input value into either a cat or a dog. So this is our problem statement. Now suppose there are two categories, category A and category B. We have a new data point x1. So this data point which will lie in these categories. To solve this problem, we need a KNN algorithm. With the help of KNN, we can easily identify the class of the category of the dataset. So just look at this diagram. Here you have two different categories. So all the data points of type category A are marked in blue, and all the data points of category B are marked in orange. Now this is before KNN. So now you have a new data point in dark blue color, and you want to classify it into category A or category B. So once you apply KNN on this dataset and on the new data point, so it will be marked as light blue color, and finally we can classify this new data point into category A. So again, we have solved this classification problem with the help of the KNN algorithm. So let us understand how does KNN actually work. So the KNN working can be explained on the base of the following algorithm. So these are some of the steps of the KNN algorithm. So first we have to select the number of neighbors. So we want to select the nearest number of neighbors that we're going to use for comparison, and then we'll calculate the Euclidean distance of the new data point from all the nearest neighbors that we have selected. Let's say we have assumed 5 nearest neighbors for comparison. Then we'll calculate the Euclidean distance from the new data point to the all 5 neighbors that we are taking into consideration. Now take k nearest neighbors as per calculated Euclidean distance. This we already discussed. Among these k neighbors, count the number of data points in each category. Assign a new data point to the category for which the number of neighbor is maximum and our model is ready. So let us understand with the help of this image. Suppose we have a new data point and we need to put it in required category. So here category A is in light blue color and category B is in dark blue color, and we have a new data point in orange colored mark. Now we want to classify it into either category A or category B. So let us say we assume that we are going to take k is equals to 3, that the number of nearest neighbors of this data point, and we are going to consider 3 nearest neighbors for this data point. So 3 nearest neighbors will be these 3 ones, and based on the Euclidean distance that will calculate in the real problem. But here by just doing a common observation, we can classify these 3 will be the nearest neighbors for this new data point. Now from these 3 neighbors, 2 belong to the dark blue category and 1 belongs to the light blue category. So by using the majority vote, like the majority stands for dark blue category, so this new data point will be classified into a dark blue category. So this is how KNN works. So this is the mathematical visualization for the same. Firstly, we'll choose the number of neighbors, and here let's say we choose k is equal to 5. Next we'll calculate the Euclidean distance between the data points. The Euclidean distance is the distance between 2 points, which we already studied in geometry. So Euclidean distance is basically under root of x2 minus x1 whole square plus under root of y2 minus y1 whole square, and you just have to take the root of the entire value. So let's say if I want to this is a standard coordinate xy plane, and these are 2 points on the xy plane. The coordinates of point A are x1 and y1, and the coordinates of point B are x2 and y2. And if I want to calculate the Euclidean distance between these 2 points, I'll simply do under root x2 minus x1, the value of x2, I'll subtract it from x1, and then I'll take the square of this value, and then y2 minus y1, I'll square the whole value. Now whatever value that I get as an answer, I'll take the under root, and this entire thing will be known as the Euclidean distance. This is very simple high school coordinate geometry. I hope you are very clear with this concept. Now here category A, if you look at this image very carefully, category A has 3 nearest neighbors and category B has 2 nearest neighbors. So for this example, we are considering the value of k equals to 5. So we are going to take in account 5 nearest neighbors, and from the 5 nearest neighbors that we are using, 3 belong to category A and 2 belong to category B. So as category A has more number of nearest neighbors to the new data point, so this new data point will be classified into category A. This is simple logic of KNN. I hope you are clear with the mathematical understanding of KNN. Now let's move to the Jupyter Notebook and implement the KNN algorithm practically. So let us start with the practical implementation of KNN. First of all, I have already done all the code in Jupyter Notebook just to reduce the length of the video, and I'll explain everything very quickly to you, because most of the life cycle of the machine learning algorithm or the project remains the same. Only the algorithm, the implementation of algorithm in the sklearn, that changes. So first of all, I'll import the required libraries. I have NumPy, Matplotlib and Pandas. Now this is a data set that I'm storing in a Pandas data frame, user data.csv, by using pd.readcsv. Now I'm extracting dependent and independent features. So on my, first of all, have a look on the data set. So we have gender, age, estimated salary, and the target that we are predicting is purchased. So we have 2 categories, purchased or not purchased. So if we have 0 in the section of purchase, then the customer has not purchased, and if we have 1, then he or she has purchased. Then we are separating the target and independent features. Now we are using sklearn.model selection train test split. I'm using 75% of data for training and the test size is 25%. XY, Xtrain, Xtest, Ytrain, Ytest. Now it is a good habit to perform scaling if you're working with algorithms like KNN and or a neural network. So just to improve the results, I'm using the standard scaler. So I'll make the instance of the scaler and then Xtrain fit transform and xtest only transform. So this is for scaling. Now we have the data scaled. Now okay, let me add one more cell and show you xtrain how it looks after scaling. So now we have both the features perfectly scaled between -1 to 1. Now what we are doing from sklearn.neighbors, so I'll import the k nearest neighbors classifier. So this is the algorithm that we're going to use. So I'll import it, then I'll make the classifier instance, and I will choose nearest neighbors as 5. So I'll use the nearest 5 neighbors and calculate the Euclidean distance, and based on it I'll predict the value of the new data point. These are some of the hyperparameters that we're not going to discuss in detail. Now I'll use the fit method and I'll train the model on xtrain and ytrain. So classifier.fit xtrain ytrain. Now I have the instance of the model. Now let us make some predictions. So predicting the test result. So we have the predict method and we are going to predict the value of xtest. So I'll pass xtest and then I'll store the predictions into ypred variable. Now let us analyze the results what we have achieved. So as you can see from the confusion matrix, actually the algorithm is working quite good. So we if you see the diagonal elements, we are having a huge a large amount of values are present in the diagonal elements, true positive and true negative. So the accuracy is quite decent. Now these two cells are for visualization. So this is the visualization for the code is for visualization of the training set, and this is the visualization for the testing set. So here we have estimated salary and here I have age, and then I'm predicting based on these two features. This is for the test set and this is for the train set. So you can have a look at the visualization and try to understand the algorithm in a better manner. I hope you are clear with the working of KNN, and now let's move to the and welcome to the video on SVM. SVM stands for support vector machine. So SVM or support vector machine is one of the most popular supervised machine learning algorithms, which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of SVM algorithm is to create the best line, or we can call it a decision boundary, that can segregate n-dimensional spaces into different classes so that we can easily classify the new data point into correct category in the future. Now the best decision boundary is called a hyperplane. Hyperplane is one of the most important and frequently used terminology while we are going to study SVM. So it is the best decision boundary in SVM. So SVM chooses extreme points or the vectors that will help in creating the best or the optimum hyperplane. Now these extreme cases are called as support vectors. Hence the algorithm is termed as support vector machine. So consider the below diagram in which there are two different categories that are classified using a decision boundary or a hyperplane. So in this diagram, as you can see, the two most extreme points of both the green and blue category are known as the support vectors, and this is the maximum margin or the distance separating those 2 points, and this is the maximum margin hyperplane. This is on the right side we have the positive side of the hyperplane, and on the left side we have the negative side of hyperplane. And here for the ease of understanding I'm using a 2D dimensional space or a coordinate axis, but in real life problems you can have a n dimensional vector space. So this is the basic working of SVM. Now have a look at this diagram. Here what we have some labeled or training data. So we have two different types of images in the data set. One is for cat and another is for dog. So as usual in the machine learning procedure that we follow, let's say we use the 80% data for training the model. This is the labeled data. So each image will have a label whether it's a cat or a dog. So all this 80% of the data will be given to the model for training. Now this new data point, and this will be a non-labeled data point. Once the model is trained, it will be given to this model, and finally based on the patterns that it has extracted from the training data, the model will predict that this new data point, it's a cat. So this is how the SVM works, just like any other supervised machine learning algorithm. Now let's study about the different types of SVM. So SVM can be of two types. The first one is linear SVM. Linear SVM is used for linearly separable data, which means if a data set can be classified into two classes using a single straight line, then such data is termed as linearly separable data, and classifier is used as linear SVM classifier. So again, going back to the image, all the data points inside the data set can be just separated by a single linear straight line. So this is an example of linear SVM. Another slightly complex version that we have is a non-linear SVM. So non-linear SVM is used for non-linearly separated data, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used is called non-linear SVM. So we can tune the hyperparameters in SVM, and we can fit the SVM function on linear or non-linear data. That is about the coding part, and we'll discuss it once we are done with the theory presentation. So important terms in SVM, the hyperplane and support vectors. So hyperplane, there can be multiple lines or decision boundaries to segregate the classes in n-dimensional space. But we need to find out the best decision boundary that helps us to classify the data points. So this best decision boundary is known as the hyperplane of SVM. The dimensions of a hyperplane depends on the features present in the dataset, which means if there are two features present in the dataset, then the hyperplane will be a straight line, and if three features are present, then the hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between two data points, so it can separate the data points very clearly, and we want the best fit hyperplane. And again, the support vectors, so the data points or the vectors that are closest to the hyperplane. So once we have found out the hyperplane, the plane that is separating two different classes, and the data points that are closest to that particular hyperplane that we are using, that is known as the support vectors, which affect the position of hyperplane, are termed as support vector. Since these vectors support the hyperplane, hence these are called the support vectors. So let's understand with this practical example. So the working of SVM algorithm can be understood by using, suppose we have a dataset that has two tags, green and blue, and a dataset has two features, x1 and x2. We want a classifier that can classify pair x. Suppose we have a new data point x1 x2 with the coordinates x1 and x2, and we want it to be classified into a green or a blue category. So in this image, now what we can do, suppose it's a 2D space. So just by creating or using a single straight line, we can easily separate these two classes, but there can be multiple straight lines that can separate these classes. So we can have this brown kind of straight line, or we can also have this green straight line. Both these lines are clearly able to separate blue and green classes, but the SVM algorithm helps us to find the best fit line or the decision boundary that we can use. So this best boundary or region is called a hyperplane. So this is the optimal hyperplane based on the distances calculated from the support vectors. So this is where the role of SVM comes into picture. So SVM algorithm finds the closest point of the lines from both the classes. These points are called the support vectors that we already discussed. The distance between the vectors and the hyperplane is called the margin. This is a new term. So the distance between the optimal hyperplane that the SVM is determining and the support vectors is called the margin, and the goal of the SVM is to maximize the margin. So based on the maximizing the margin, this is the concept. So based on that, from whichever hyperplane we are getting the maximum margin, that will be considered as the optimal hyperplane by SVM. So the hyperplane with maximum margin is called the optimal hyperplane. So this is the core concept of SVM. I hope you are very clear with this. Now let's move to the Jupyter Notebook and try to implement SVM. Let us start with the practical implementation of SVM. First of all, I'll import pandas as pd and import numpy as np. Then I'll create one data frame to store the CSV file that we are going to be using for the SVM. So that's called as df is equals to pd.read underscore CSV, and here I'm going to use user data.csv. So let's see what do we have inside our data frame. So the entire CSV file is loaded. Now next thing what we can do, we can separate the dependent and the independent features, basically the x and y that we use. So for x, I can use df of I want age and estimated salary. So these are the two features that I'm going to use for X, or maybe the independent features. And the dependent features that we are trying to use or basically predict is purchased. Now let's see what do we have inside X and Y. Okay, so X dot, so age and estimated salary are the independent features, and we have Y dot head, the purchased column, that is we are trying to predict. So let's train and split the data set into training and testing. So from sklearn dot model underscore selection import train test split. Now I'll make x train, x test, y train and y test. So x train, then I have x test, then y train, and finally y test. This will be train test split, and the features are x and y, and I will use 80% data for training, so the rest 20% will be for testing. So this is done. Now let's import the SVM classifier. So from sklearn dot svm, as we are solving a classification problem, so I will import svc, that is support vector classifier. So it is done. Now let's make the classifier instance. So svc, and we are going to use the linear kernel that we already discussed in the theory part. So you can change the hyperparameters and tune them and check the results accordingly. For this I'm going to use the linear kernel, and let me run this cell. So kernel, okay, we have made a spelling error, so this is kernel. Now let's train it with the help of x train and x test. So we'll use the fit function, and I'll give x train and y train. So the model will take some time to train. Once it is done, you will get something like this. Now let's make some predictions. So I'll write ypred clf, and I'll call the predict method, and I'll give x test over here. So we have all the predictions inside the ypred. Let's see what is there. So ypred, all the 0 1 0 1 0 1 that the model has predicted. So now what we can do, we can check the accuracy of the SVM. So from sklearn dot matrix import accuracy underscore score. So these are the this is the accuracy score metric that the sklearn gives us to check the accuracy of a classifier. So I can write accuracy underscore score, and here I have my y test, and then I'll give my ypred. So it will compare the results that are stored in the y test, and it will also with the results that the model is predicting, and it will tell us the accuracy. So the accuracy that we are getting is about 86.25%. That is actually a pretty decent accuracy for without doing much hyperparameter optimization. So SVM is working quite good on the dataset that we are using. So I hope you are clear with working of SVM and also the practical implementation of SVM. Now let's move to the next video. Thank you. Hello and welcome to the video on decision tree algorithm in machine learning. So decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly we use decision tree to solve the classification problems. So it is a tree structure classifier where internal nodes represent the features of the dataset, branches represent the decision rules, and each leaf node represents the outcome. So in a decision tree there are two nodes, which are the decision node and the leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branch. So the decision or the test are performed on the basis of features that are given in the dataset. So it is a graphical representation for getting all possible solutions to a problem based on the given conditions. We call it decision tree because the structure is similar to a tree, and it starts with a root node which expands on further branches and constructs like a tree. So in order to build a decision tree, we use the CART algorithm, which stands for classification and regression tree algorithm. As already discussed, we can perform both classification and regression tasks with this algorithm, hence the name CART. So a decision tree simply asks a question based on the answer yes or no, and it will split the tree into next subtree structure. So by seeing this image you will get more clarity. This is the decision node or the root node. Now based on a certain if else condition, we will split this decision node into two subtrees. So this is one is entire subtree and this is another entire subtree. Now these all leaf nodes are having the decisions made by all these subtree structures. So why do we use decision trees? There are various algorithms in machine learning. So to choose the best algorithm for the given dataset, the main point to remember is that decision tree they usually mimic human thinking ability while making a decision, so it is easy to understand. Now the logic behind decision tree can be easily understood because it's just a tree like structure, so we can easily derive back the logic based on which the decision was made or the prediction or the classification was made. Now few important terminologies before moving on to the decision tree working. So root node is from where the decision tree starts. So the first or the top node is known as the root node. It represents the entire dataset, which further gets divided into two or more homogeneous datasets. So once we make two or three splits on the root node, then the entire dataset is divided into two or three subtree structures. Now leaf node is the final output node, and tree cannot be segregated further after reaching to a leaf node. Splitting is the process of dividing the decision node or the root node into subnodes according to the given conditions. Here we want to see this term called branch or a subtree. So a tree that is performed as splitting the tree. So this is the subtree that we are getting. Pruning is the process of removing unwanted branches from the tree. This is very similar to the gardening term that we use, pruning. Parent and child node. The root node of the tree is called the parent node and other nodes are called the child nodes. Now have a look at this picture and we'll try to solve the example. So suppose there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. This is our main problem statement. Now to solve this problem, the decision tree starts with the root node salary attribute. So salary will be considered as the root node as the parameter of making the decision. So the root node splits further into next decision node, that is distance from the office, whether office is located close to home or not, and one leaf node based on corresponding labels. The next decision node further gets split into one decision node cap facility, this is another factor, and one leaf node. Finally the decision node splits into two leaf nodes accept the offers and decline the offer. So here as we are taking salary is between 50,000 to 80,000, this is the root node. If yes, then we'll think further about the location of the office. If the salary is less than $50,000, then straight away we'll reject or decline the offer. So no further questioning, we cannot accept that offer. But if the salary ranges between 50,000 to 80,000, then this path will be taken and the next question will be asked whether the office is near to home or not. Again, if the office is not near to home, declined. So this is another decision, offer declined. But if the office is close to home, then we'll ask the next question. Does the office provides cab facility? If yes, then we'll finally accept the offer. So to accept the offer, we have to take this part and all the conditions should be satisfied. Otherwise, on the other side of the tree, that we can straight away decline the offer. Now finally, let us understand some of the disadvantages of using a decision tree. So the decision tree contains a lot of layers, which makes it slightly complex. Sometimes checking too many conditions, it becomes a little complex. Now this may also lead to an overfitting issue, which can be resolved by using the random forest algorithm. This is another very important and very super powerful machine learning algorithm that we are going to cover in the next few videos. For more class labels, the computational complexity again of the decision tree may increase. So these were some of the disadvantages of decision tree. I hope you are clear with the basic concept and working of decision tree. Now let's move to the Jupyter notebook and try to implement the decision tree algorithm in sklearn. Hello and welcome to the practical implementation of decision tree. So let us start. Import pandas as pd, import numpy as np. Now I'll create one data frame and we'll use the user data.csv that we were seeing in the videos of logistic regression and other classification algorithms. So df is equal to pd dot read underscore csv and we have user underscore data dot csv. So let's check our df. So this is the dataset that we are working with. Now we'll extract the dependent and independent features. So what I'll do, x will be df of I'll use gender and let's say age, and the third one is estimated salary, and y will be df of purchased. So this we have separated our dependent and independent features. Now let's import from sklearn dot model underscore selection, import train test split. Now I'll make x train, x test, y train and y test. So x train, x test, y train, and then I have y test. This will be train underscore test and then split. Here I will give x and y, and my test underscore size will be of let's say 20%. So this I have separated my x train and x test. Now we'll import the decision tree classifier. So from sklearn dot tree import decision tree classifier. Then I'll make one instance for the classifier, that is clf, and decision tree classifier. So the clf is trained. Let me mention the criteria that we want to use, that is the entropy. So criterion, that will be entropy. So again I have a train classifier. Oh, I have my instance ready. Now let's train this. So clf dot fit method, and I'll train it with x train, and I have y train. So this is training. Okay, could not convert string to float. Okay, we have this we are using the gender attribute, that is a categorical variable, and so we are not going to perform the feature encoding. So as of now let's remove the gender attribute and work with the remaining two. So now this classifier is ready. Now what we'll do, let's make some predictions. So y underscore pred will be clf dot predict, and we want to predict on x test. So these are all our predictions. Now let's see what do we have inside y pred. So all 10 10 10 the predictions that we have. Now let's import from sklearn dot matrix import accuracy score. So we'll be working with, we'll try to find the accuracy of our model. So accuracy underscore score. Now what we'll do, accuracy score, this will be y test and y pred. So we are getting a very good accuracy of 87.5%, which is actually a really good accuracy for a machine learning model. So this was the practical implementation of decision tree. We used the user dataset to predict whether the customer will purchase the item or not based on the gender, age and estimated salary, and we are getting accuracy of 87.5%. So I hope you are clear with how decision tree works. Now let's move to the next video. Thank you. Hello and welcome to the video on random forest algorithm. Random forest is one of the most popular machine learning algorithm that belongs to the supervised learning technique. Again, random forest can be used for both classification and regression problems. It is based on the concept of ensemble learning, which is process of combining multiple classifiers to solve a complex problem and then improve the performance of the model. So most of the time, if you try a few different algorithms like logistic regression, SVM, KNN, decision tree and random forest on different classification problems, most of the time random forest will be best performing model without any hyperparameter optimization. So this is a go-to ML algorithm for most of the ML engineers out there. So as the name suggests, random forest is a classifier that contains a number of decision trees on various subsets of a given dataset and takes the average to improve the predictive accuracy of that dataset. Now, instead of relying on one decision tree, the random forest takes the prediction from each tree, and based on the majority votes of predictions, it predicts the final output. So the greater number of trees in the forest leads to higher accuracy, and it also prevents the problem of overfitting. If you remember carefully from the video of decision tree, in the disadvantage section of the decision tree, we mentioned that sometimes due to the increasing length of decision tree, it tends to overfit on the data. So this problem can be prevented by using random forest. Now this is a visual representation of how random forest works. So training data set 1, training data 2, training data n. Now again you have a first decision tree, second decision tree and the end decision tree. Now you take the voting or averaging of all the decisions given by these different decision trees on different subsets of training data, and finally after averaging you give the final prediction. Now this is how random forest works. Now let's take one example. So suppose there is a data set that contains multiple fruit images. So this data set is given to random forest classifier. The data set is divided into subsets and given to each decision tree. So here you have a dataset that contains multiple fruit images. Now this dataset is given to random forest, and this dataset will be divided into subsets, and each subset is given to a new decision tree. So during the training phase, each decision tree produces a prediction result. So this decision tree, let's say, predicts that this belongs to class A. The second decision tree tells that this belongs to class A, and the third or the nth decision tree tells that this belongs to class B. Now then, when a new data point occurs, then based on the majority vote results, the random forest classifiers predicts the final decision. So as the majority vote is for class A, so the final predicted class will be class A based on the entire random forest algorithm. So this is how the random forest algorithm works. I hope you are very clear with the working of random forest algorithm. Now let's move to the Jupyter notebook and try to implement and see the accuracy that we are able to achieve by simply using random forest algorithm. So let us start with the practical implementation of random forest. First of all, let me import pandas and numpy. So import pandas as pd and import numpy as np. Okay, we have here pan, import pandas as pd. Now what we'll do, I'll import the dataset as a data frame. So df.pd.read_csv, and here I am using user data.csv, and let's see what do we have inside the dataset. So these are the attributes that we have inside the dataset. Now we'll split up the x and y or the dependent or independent features. So df of the independent features will be age and let's say estimated salary. So we are using these two columns to predict whether the customer will purchase or not. So df of purchased. Now after this, let me split the dataset into training and testing part. So from sklearn.model_selection, import train test split. It will take some time to import and it's done. So I'll make my X train, then I have X test, then Y train and Y test. This is train test split and I'll use X and Y. I want to use 20% data for testing, so test size will be equal to 0.2. So now I have my X train, X test, Y train and Y test. Now let us import our random forest classifier from the sklearn.ensemble. So from sklearn.ensemble import random forest classifier. So now I'll make one classifier instance. So CLF will be random forest classifier. As of now, I am not giving any specific hyperparameters. I want just a default classifier and I want to train this. So I'll use the fit method and I'll train it with the help of X train and Y train. So X train and I have Y train. So based on this, I'll train my random forest classifier. Now next thing I want to do, I want to check the predictions. So Y pred will be equal to CLF dot predict and I want to predict X test. So all the predictions will be stored in ypred. As you can see, we are getting all 0 1 1 0, all the predictions. Now let's check the accuracy that we were able to achieve with the help of the random forest model. So from sklearn dot matrix import accuracy score. Now I will write accuracy score is let's say Y test and Y pred. So again we are getting 87.5% accuracy by using the random forest classifier. So for a normal machine learning model without performing any hyperparameter optimization, we are able to achieve such a good score of 87.5%. So I hope you are clear with the practical implementation and basic understanding of random forest. Now let's move to the next video. Thank you. And welcome to the video on k-means clustering algorithm. This is the first unsupervised machine learning algorithm that we are going to cover in our course. So let us start. K-means clustering is an unsupervised learning algorithm which groups the unlabeled data into different clusters. Here, K defines the number of predefined clusters that need to be created in the process. As if K is equals to 2, there will be 2 clusters created, and if K equals to 3, there will be 3 clusters created, and so on. So it is an iterative algorithm that divides the unlabeled dataset into K different clusters in such a way that each dataset belongs only to one group that has the similar properties. Now it allows us to cluster the data into different groups and a convenient way to discover the categories of groups in the unlabeled dataset on its own without any need of training. As this is an unsupervised learning algorithm, so we don't have that training, testing and all that part that we used to do in algorithms like random forest, decision tree, logistic regression, etc, etc. So it is a centroid based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distances between the data point and their corresponding clusters. So this is the graphical representation of k-means algorithm. So before applying the k-means clustering, this is a simple scatter plot of the data that we had. Now once we performed k-means clustering on this data, now we have something like this. So this one is considered as one single blue cluster. This green one is the second cluster on the top, and third cluster is the black dots that we have on the right hand side. So let us understand how does the k-means algorithm work. So the working of the k-means algorithm is explained in the below steps. So the step 1 says that we have to select the number k to decide the number of clusters. Now we will see the elbow method that is used to determine the number of clusters that we are going to make from the dataset. So the first step is to decide the number of clusters that we want to create. For that, I'll teach you about an elbow method later in this video. Now second, select random k points or centroids. It can be other from the input dataset. Now step 3 says that assign each data point to their closest centroid, which will perform the predefined k clusters. Now step 4, calculate the variance and place a new centroid of each cluster. Repeat the 3 steps, which means assign each data point to a new closest centroid of each cluster. If any reassignment occurs, then go to step 4 or finish it. Now the model is ready. So let us understand this. Suppose we have two variables m1 and m2. The xy axis scatter plot of these two variables is given below. So this is a scatter plot. Now let's take number k of clusters. We want to make two clusters out of the scatter plot and the dataset and to put them into different clusters. It means here we will try to group these datasets into two different clusters. Now we need to choose some random k points or centroid to form the cluster. So these 2 points can either be the points from the dataset or any other point. It doesn't matter. So here we are selecting the below 2 points as the k points. So we are selecting these 2 points as the initial cluster centroids, which are not the part of dataset. So these 2 points are not the part of dataset. We are selecting them as the initial cluster centroid. Now we will assign each data point of the scatter plot to its closest k point or centroid. We will compute it by applying some mathematics that we have studied to calculate the distance between 2 points. So we'll draw a median between both the centroids. So from the above image, it is clear that the points on the left side of the line lie near to k1 or the blue cluster center, and points to the right side of the line are close to the yellow centroid. So let's color them as blue and yellow for clear visualization. So after this is the initial two clusters that we have made after selecting a random centroid. Now as we need to find the closest cluster, we will repeat the process by choosing a new centroid. To choose new centroids, we'll simply compute the center of gravity for these centroids and we'll find new centroids as below. Now we will reassign each data point to the new centroid. For this, we will repeat the same process of finding the median line. The median line will look like the given image. So this is after changing the center of gravity for the clusters. Now we can see one yellow point is on the left side of the line and two blue points are on the right side of the line. So now these 3 points will be reassigned to the new centroids. Finally, it will look something like this. So all the blue points are on the upper side of the line, and the yellow points are below the line. So as reassignment has taken place, we will again go back to the step 4, which is finding new centroids or k points. So we'll repeat the process by finding the center of gravity of centroids. So the new centroids will be shown in the below image. Now we got new centroids. So again we'll draw the median line and reassign the data points. So the image will look something like this. Finally, we can see in the above image there are no dissimilar data points on either side of the line, which means our model is formed. In this image, now our model is ready and we can remove the assumed centroids and 2 final clusters will be shown as you can see in this image. So this is how k-means clustering works. I hope you are very clear with the basic working of k-means. Now let's move to the practical section and try to implement it in the Jupyter notebook. So let us start with the practical implementation of k-means algorithm. In this cell I have imported all the required libraries. So we'll be using NumPy, Matplotlib and Pandas. So importing the dataset inside a Pandas data frame. So mol customers.csv by using pd.ratecsv. Have a look at this dataset. We are having customer ID, gender of the customer, age of the customer, annual income in $1,000 and spending score in 1 to 100. So based on all the features, all the different features that we have for the customers in our dataset, we have to cluster them. So a practical use case of this k-means or customer clustering approach can be the retail store or the online store can throw up different offers to the different customers falling in different clusters. Let's say a customer with the high annual income and high spending score will receive the offers for slightly expensive things, and in case if a customer is not that old or has a low income or does not have a very high spending score, so the store can pitch or sell or advertise cheap products to that customer. So based on the cluster of that customer, the store can advertise different products. So this can be used for effective marketing. So this is the data set that we're going to use. Now these are all the features that we are going to take into account, and here in unsupervised learning techniques we don't have to use the x and y or the dependent or independent features. We just simply have to choose the features from the data set. So if I add one more cell and if I write x over here, so these are the two features that we are going to use. So annual income and spending score. Now moving on, as I told you, we are going to use something called an elbow method to find the optimum number of clusters. So the code for elbow method is given over here, and the full form for WCSS is within cluster sum of squares. We are not going to go in a lot of mathematical detail about this elbow method, but simply by using the elbow method you can plot this elbow shaped graph, and the optimum number of clusters will be the point on the graph where the graph starts to flatten. So here in our case, this can be the optimal cluster point or the elbow point of the graph. So this is for 2, 3, 4 and 5. So this is almost 5. So we can get a decent idea about the number of clusters. So based on this elbow graph, we can directly say that the number of clusters that we are going to make from the given dataset will be 5. You can try the code for elbow method on different datasets and try to figure out the optimum number of clusters as a practice. So here I am calling the k-means model, and the number of clusters that I am going to use is 5. And then k-means dot fit predict. This is the method fit predict that we are going to use when you're working with unsupervised learning algorithm. Now here, as we are not predicting a certain value, so there's no point of accuracy or any other metric. So we'll simply visualize all the clusters that we have made. The code for visualizing the clusters is given over here. Clusters of the customer, annual income is on the x-axis and spending score is on the y-axis, and based on all the both the features we have created 5 different clusters: light blue, dark blue, pink, red and green. So these are the 5 different clusters that we have created, and the yellow ones, the yellow dots are for the cluster centroids. So this was the working of k-means clustering algorithm. I hope you are very clear with this. Hello and welcome to the video on hyperparameter optimization using grid search CV. So first of all, let us understand what are parameters and hyperparameters in machine learning. Before we dive into tuning your hyperparameters, let us take a moment to recap what the differences are between the parameters and the hyperparameter in the machine learning model. So, parameters in a machine learning model refer to the variables that an algorithm itself produces, such as coefficient, let's say, to produce a prediction. Now, these parameters are not set or hard coded and depend on the training data that is passed into your model. Because of this, they are likely to change as the data changes. On the other hand, hyperparameters are variables that you specify while building a model. This means that it's a user that defines the hyperparameter while building the model. For example, in KNN algorithm, the hyperparameter can be as the value of k, that is the nearest neighbors. Such as in algorithms like in decision tree or random forest, the hyperparameter can be the depth of the tree or the number of trees, like that. Now in short, hyperparameters control the learning process while parameters are learned. This is the key statement. Hyperparameters control the learning process and parameters are learned. So this is where the art of machine learning comes into play. The choice of your hyperparameters will have a significant impact on the success of your model. So being able to tune your model is and finding the best hyperparameter is very important. So hyperparameter tuning in machine learning. Hyperparameter tuning refers to the process of finding the hyperparameters that yield the best result. This of course sounds a lot easier than it actually is. Finding the best hyperparameter can be an elusive art, especially given that it depends on largely the training and the testing data that you are using. So as your data evolves, the hyperparameters that were once high performing may not perform well. Keeping the track of the success of your model is critical to ensure that it grows with the data. So one way to tune your hyperparameters is to use a grid search. This is probably the simplest method as well as the most crude. In a grid search, you try a grid of hyperparameters and evaluate the performance of your model on each combination of the hyperparameters. So we'll try each combination that we give in the grid. So this is about grid search CV. Now let's explore the grid search CV class. So in the grid search CV, the first argument that we can give is the estimator or the sklearn model that we are using. It can be any model, random forest, decision tree, KNN, logistic regression, any model that you want to use. Paramgrid, this will be a dictionary of parameters with names and values. So a parameter for KNN model can be the number of nearest neighbors, but a parameter for a random forest may be the number of decision trees or the length of the decision tree. CV, an integer that represents the number of k-folds. Scoring, the performance measure such as R2 or precision. So let's say you are working with a random forest regressor, then the performance metric can be the R2 score as it's a regression problem. But if you're working with a classification problem with the same random forest algorithm, then the performance metric can be the precision, accuracy, or recall, anything that you want. N jobs, the number of jobs to run in parallel. Verbosity 0 to 3, the higher being more. This basically gives you the information about the steps of the running. Now, again, estimator takes an estimator object, such as classifier or a regression model. Paramgrid, it takes a dictionary or a list of dictionaries. The dictionary should be in key value pairs, where the key is the hyperparameter and value are the cases of the hyperparameters that the values that we want to test. CV takes an integer that determines the cross validation strategy to apply. If none is passed, then automatically 5 will be used. Scoring, this is a string or a callable. This represents the strategy to evaluate the performance of the test set. Now n jobs represents the number of jobs to run in parallel. Since this is a time consuming process, running more jobs in parallel, if your computer can handle it, can speed up the process. Verbose determines how much information is to be displayed. Using a value of 1, it displays the time for each run. 2 indicates that the score is also displayed. 3 indicates that the fold and the candidate parameter is also displayed. So I hope you are clear with the basic concept of grid search CV and hyperparameter optimization. Now let's move to the Jupyter notebook and perform the practical for grid search CV. So let us start with the practical example of grid search CV. First of all, I will import all the necessary libraries. So import sklearn dot datasets. Okay, here I need to write from sklearn dot datasets import load breast cancer from sklearn dot matrix import classification underscore report, and we'll also use the confusion matrix confusion underscore matrix from sklearn dot svm import svc from sklearn dot model selection import grid search CV, and again from sklearn dot model selection import train test split. So what in this example I'll show you how to find the best parameters for a support vector classifier or a SVM model, and we are going to use the breast cancer data set and try to solve the classification problem. So let's load the data set. So data set will be equal to load breast cancer. So X will be our data set dot data and Y will be our data set dot target. Now let's perform the train test split. So I have X train, X test, Y train, Y test, that will be equal to train test split, and then I have X, Y test size, let's keep it 20%, and then let's fit the model first without using grid search CV. So let's see how it is performing. So SVC and then model dot fit on X train and Y train. Now let's make some predictions. So predictions will be equal to model dot predict, and we want to predict for X test, and let's get a classification report for our Y test and predictions. So this is the initial classification report for without using the grid search CV. Now let's define a parameter range that we are going to use for grid search CV. So various parameters for SVM can be the C value, gamma, and let's say the kernel. So I'll make one param grid. So let's write param grid and a dictionary. The first thing that I want to get is C, and this will be a list of values. Let's say 0.1, and then I have 1, then 10, and then 100. Then I want to get the optimum gamma value. So again a dictionary 1, 0.1, then 0.01, then 0.001, and then 0.0001. Again gamma. So the scale or auto, and the last thing is the kernel. So as of now let's go with the linear kernel, otherwise it will take a lot of time to run. And then now let's make this grid. So grid search CV, the model that we're using is SVC, then we have our param grid, and then refit will be equal to true, verbose will be equal to 3, and an underscore jobs will be equal to -1. Now let's fit this grid. So grid dot fit X train, Y train. So this will take some time to completely run, and then after this runs successfully, we'll get the best parameter after the tuning. So let's wait till the grid is fitting. As I told you that if we don't specify the number of CVs, then it will automatically go with the 5 folds. So here, to get the list of best parameters, what I can write, grid dot best underscore params underscore. This will give me the list of best parameters once the grid is done fitting. Then I can write grid underscore predictions and will make predictions from this grid. So predict, again I have X test, and finally I can get the classification report. So the best parameters that I'm getting is the value of C should be 10, gamma scale and kernel is linear. So these are the best parameters, and based on this, if we run the model, then I'll get a better result. Now finally I can print the classification report. So classification report, and this will be again for Y test, and here I'm going to use the grid predictions. First of all, I have to run this cell, and then I can run this thing by using the optimum parameters. This is the perfectly tuned model. So this was about the practical implementation of grid search CV. I hope you are clear with this concept. Now let's. Hello and welcome to the video on machine learning pipeline. In this video, I'll teach you the basic concepts and also show the practical implementation of the machine learning pipeline. So in our various data science or ML project, this is the typical workflow. So firstly, we try to collect or load or get the data, CSV data basically, that we are working on. Then we perform the data pre-processing, data cleaning, feature encoding, feature transformation, etc. etc. Once the pre-processing and cleaning steps are done, then we finally move to the modeling part, and then if we want to deploy it on a cloud or a web service, then we can deploy our entire project. So this is a typical workflow of a machine learning project. Now usually what we do, we try to perform all the steps one by one. So firstly we'll just get the data by read CSV, then we will clean the data or fill the missing values, and then finally we'll train the model and evaluate the model and finally deploy it. But we can perform all the steps in a single and a more efficient piece of code, that is the machine learning pipeline. So as you can see, what is a machine learning pipeline? A machine learning pipeline is a process of automating the workflow of a complete machine learning task. It can be done by enabling a sequence of data to be transformed and correlated together in a model that can be analyzed to get the output. A typical pipeline includes raw data input, features, output, model parameters, ML models, and predictions. Moreover, an ML pipeline contains multiple sequential steps that perform everything ranging from data extraction and pre-processing to model training and the deployment in machine learning in a modular approach. It means that in the pipeline, each step is designed as an independent module, and all these modules are tied together to get the final result. So to understand the importance of a machine learning pipeline, let us first understand the typical workflow of an ML task. So machine learning workflow, first we have the data ingestion, then we have cleaning, pre-processing, modeling, and finally deployment. So a typical ML workflow contains ingestion, data cleaning, data pre-processing, modeling, and deployment. So what happens in a machine learning pipeline? The cleaned data, so the output of one step is given as the input to the next step, as the name pipeline suggests. So the cleaned data is given as the input for feature encoding or whatever stuff that we want to perform in the pre-processing step. Then once we have cleaned plus pre-processed data, then that data will be given as the input to the model on which it will be trained, and finally then that will be deployed and evaluated. So this is the typical machine learning workflow, and we can improve that with the help of a machine learning pipeline. So in ML workflow, all these steps are run together with the same script. It means that the same script will use to extract the data, clean the data, model, and deploy. However, it may generate issues while trying to scale an ML model. So some of the issues can be, if we need to deploy multiple versions of the same model, then we need to run the complete workflow cycle multiple times, even when the very first step, let's say data ingestion or preparation, are exactly similar in each model. So these are the same steps. We only want to make tweaks in the machine learning model. The preparation of the data will remain the same. Now, if we want to expand our model, we need to copy and paste the code from the beginning of the process, which is an inefficient and a bad practice in software development. If we want to change the configuration of any part of the workflow, we need to do it manually, which is more time consuming process. So for solving all the problems, we use a machine learning pipeline. With the ML pipeline, each part of the workflow acts as an independent module, and so whenever we need to change any part, we can choose that specific module and work as per our requirements. So I hope you are very clear with the basic understanding of ML pipeline and why do we use it and how it is more efficient than the standard workflow. Now let's move to the Jupyter Notebook and I'll show you the practical implementation. So let us start with the practical implementation of machine learning pipeline. First of all, to demonstrate the practical, let me import few important libraries that we will need. So from sklearn, I need datasets. I'll use the iris datasets that we have in sklearn, and from sklearn dot model selection import train test split. Next thing is one of the steps in the entire pipeline will be of scaling, so I need the standard scaler. So from sklearn dot preprocessing import standard scaler. Next thing, I'll also perform some dimensionality reduction just as an additional step in the pipeline so that the flow of the pipeline becomes very clear to you. So I'll perform something called the principal component analysis for dimensionality reduction. So I need to import that. So from sklearn dot decomposition import PCA, and finally a machine learning model that we are going to use. So let's use a decision tree. So that will be the model on which the entire pipeline, the ML pipeline will be trained. So sklearn dot tree import decision tree classifier. So we have imported all the required libraries. Now let's load the dataset. So iris is equals to data sets dot load underscore iris, and inside x we have iris dot data and y will be the target. So iris dot target. So let's see what do we have inside x and the target y. So the dataset is loaded. Now let's split the data. So x train, x test, y train and y test will be train test split. We'll use the x, y and test size will be, let's say, 20%, so 0.2. This is it. Now let's import the pipeline. So from sklearn dot pipeline import pipeline. Now let's create the pipeline flow. So I'll make one pipe and this will be a pipeline object. So pipeline, the first thing that we are going to use is to perform the dimensionality reduction. So I'll do something like this, and inside this I will give here the PCA, that is principal component analysis, and I want it to be reduced to n components equal to 2. So n components that will be equal to 2. And then after that, the next thing I want to do is perform the standard scaler. So I'll write something like this std, and this will be my standard scaler. And then finally in the third step I want the decision tree classifier, the model that we are going to use. So here I'll write dt and this will be decision tree classifier. And finally, to get some details, I want to write verbose is equal to true. So this will show us some details. Now let's fit the data in the pipe. So again we'll use the same fit method. So pipe dot fit this thing. I will use X train and Y train. So the data is fitting in the pipe. Now let's check the scoring of the data. So from sklearn dot matrix import accuracy score. So accuracy score will be Y test, and here pipe dot predict and X test. So actually we are getting a very good accuracy, almost about 100%, which can be a case of little bit overfitting, but these are all the steps of the pipeline, and then this is the accuracy. I hope you are very clear with the practical implementation of machine learning pipeline in sklearn. Now let's move to the next. Hello and welcome to the project on diabetes prediction using machine learning. So in this project we'll work with the diabetes dataset. So the dataset will contain some features like blood pressure, glucose, skin thickness, insulin, BMI, etc, etc, and based on these features we'll predict whether the person is diabetic or not. So let us start. First of all, I'll import all the required libraries. So I need pandas, so import pandas as pd. Then I want to import numpy as np. Then we can, to perform scaling, I can import standard scaler from sklearn. So from sklearn dot preprocessing import standard scaler. Next thing, we can import the train test split. So from sklearn dot model selection import train test split, and we will use the SVM machine learning model. So I can also import that from sklearn import SVM. And finally, to check the accuracy of our prediction, we can import the accuracy score. So from sklearn dot matrix import accuracy score. So this will take some time to import. Till then, I can make a new data frame and load the diabetes CSV data that we have. So I can write df will be equal to pd dot read CSV, and I have a diabetes dot CSV. Now let's see what do we have inside our data set. So the data set contains several features: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age of the person, and finally outcome. So here this is the data set that we have. Now let's check the shape of the data set, the number of rows and columns. So we can write df dot shape. So the dataset contains 9 columns and 768 rows. We can also call something like df.describe. So we'll get the description, the basic statistical measures like mean standard deviation, minimum maximum value for all the columns. So this looks fine. Now what do we have? Okay, so we'll also check whether the data is balanced or not. So I can write something like this: df of outcome dot value underscore counts. So outcome is, I think the O is capital. Okay, so I can write outcome. So 500 people are non-diabetic and 268 people are diabetic. So I can write 0 stands for non-diabetic. tick, and 1 stands for diabetic. So this is it. Now let's separate the x and y, or dependent and independent features. So I'll make x will be df dot drop, and I want to drop outcome. So columns, I want to drop outcome, and this is the column, so I'll give x is equal to 1, and y will be df of only outcome. So now we have separated our x and y. So let us check what do we have inside x. We have all the columns excluding outcome, and y, this is our target, that is outcome. Now let's perform the standardization. So I'll make one instance of standard scalar. So I'll write scalar that will be equal to standard scalar. I've made this object. Now I'll fit on x, so I can write scalar dot fit, and I'll write x over here. Now I'll call the fit transform method. So the standardized data will be stored into scalar dot, so I'll write transform, and in this transform again I'll give x. So now standardized, we have our standardized data. Let us see how our data looks after performing standardization. So we have something like this. Now let's check our final x and y. So x final, okay, will load standardized data back into x. So we can write standardized data. Okay, let me copy this, standardized data. X is something like this. So x is equals to standardized data, and if I now try to print the value of x, so this is our x and this is our final y. So we are done with our x and y. Now let's split the data into training and testing part. So I can make x train, x test, y train, and y test, and I can call train test split. Here I'll give x, y, and test size will be 20%, so I can write 0.2. So we have our training and testing sets ready. Let's check the shape of them. So x train dot shape, x test dot shape. So we have 80% of the data in training and 20% is in testing. Now we'll train the model. So I can write train the model, and I'll change it to markdown. So first of all, I'll make one classifier instance. So CLF will be SVM, and this is a classification problem whether we are trying to predict whether the person has diabetes or not. So I'll use the support vector classifier from SVM. So SVM dot SVC, and kernel I'll be using, that will be linear. So kernel is equal to linear. Now we can write CLF dot fit and train the data set. So I'll give x train and y train over here. So our model is ready. Now let's store the predictions. So I'll write, okay, first let us check the accuracy score on training dataset. So I can write x train underscore prediction, and I can write CLF dot predict and x train, and I can check the accuracy score, and I'll give y train over here, and I can give X-train prediction to check the accuracy score of training data. So 78.5%, this is the accuracy score of training data. Now let's check the accuracy score on test data. So accuracy on test data. So I can again write X test prediction. So these are the prediction for X test, and CLF dot predict, and I want to predict X test. Again accuracy score, and this one will be for X test prediction. So I'll copy this, and I have to check the accuracy with Y test. So it is 77.2%. That is a pretty decent accuracy for a SVM model and without much hyperparameter optimization. So now let us make a predictive system to predict the whether the person is diabetic or not based on the features. So I'll create sample input data from my side only. So input sample, that will be, I can make a Python tuple for this. So let's write 5, 166, maybe 72. These are all the input values for the features that we already have. So I'm just giving random values, and then we'll see what do we have in the output. So 19, then 175, then let's use a decimal, 22.7, then I can write, let's say 0.6, then I have 51. So I'm keeping the data type in check with what do we have inside our data. So the diabetes pedigree function is around the range of 0 to 1, so I'm using the same value. So I'm keeping the data type in check for the sample. Now we'll convert the this input sample into a NumPy array. So input NP array, okay, NP underscore array for clarity, and I can use NP dot as array function. So as array, and I'll give this input sample. Then finally we'll reshape the array as we are predicting only for one instance. So input NP array reshaped, and here I can write the same thing, and I'll use the reshape function that we studied in NumPy dot reshape, and I'll give 1 comma -1. So now we'll standardize the input data that we are receiving. So I can write standard data, that will be scalar dot transform, and I'll give this input NP data reshaped. So now we have standard data. So I can also print what do we have inside our standard data. So these are all the standardized values that we have. Now again we can make the prediction. So prediction will be equal to CLF dot predict, and it will predict on the standard data. So we have stored the prediction. Now let's print the prediction. So the prediction is 1. So basically the person is diabetic. So let's make a decent system to tell that. So we can do something like this: if prediction of 0, so whether it is 0, this is simple Python coding, if else condition, then we can print that person is not diabetic, and again I'll write else. If this is not the case, then simply print if we are getting 1. Basically if we are not getting 0, then we are getting 1. So this is a binary classification problem. Either a person can be diabetic or he or she cannot be. So I can write person is non diabetic. So person is non-diabetic. So this is how the system works. So this was a complete project based on diabetes prediction. So I hope you are very okay. Person is, I made a spelling error over here. So I have to write person is diabetic because we are getting 1 in the input. So the model is saying the model output is 1. That means the person is diabetic. So I have to write person is diabetic over here. So I hope you are very clear with this project. And now let's move to the next video. Thank you. Hello and welcome to the video on medical insurance cost prediction. In this video, I'll teach you how to make a project or a machine learning app that will predict the cost of your medical insurance based on the features like age, sex, BMI, smoker, region, etc. etc. So first of all, let me import the required libraries. So import numpy as np. Then I want pandas, so import pandas as pd. The next thing I want is let's say we'll try to do some data visualization and analysis, so I can import matplotlib and seaborn. So import matplotlib dot pyplot as plt, and I also want to import seaborn as SNS, and then I want to train, test and split the data. So from sklearn dot model underscore selection import train, test, split. Next thing, we are simply going to use the linear regression model that we saw in the machine learning section. So a simple linear regression model from sklearn dot linear underscore model import linear regression, then from sklearn import metrics to check accuracy and all that, etc. So df will be equal to pd dot read csv, and I want the insurance data set that I already have. So csv. Let's check what do we have inside our data. So we have features like age, sex, BMI, children, smoker, region, and charges. So based on all these independent features, I'll try to predict the cost of a medical insurance for a new person. So let's check the shape of the data. So df dot shape. The data set has 1338 rows and 7 columns. Now finally, let's check the info about data. So df dot info. So we, as you can see, we have some categorical type variables like smoker is yes or no, and region is southwest, and maybe sex is male and female. So we don't have direct numeric values for these features. So as machine learning models do not work with textual or categorical data, we have to encode the features. So first, let's check the categorical features that we have. Sex is the categorical feature, smoker and region, these three are categorical features. Now let's check, do we have some null values in the dataset or not. So we can write df dot is null, and I can call sum. So yes, the data set is cleaned and we don't have any null values. Now let's write df dot describe. So this will give the basic statistical measures for all the numeric values that we have. Now let's understand the distribution of age that we have inside our dataset. So I'll make one age distribution, the density or the maximum age density that we have inside the dataset. So I'll use some seaborn and matplotlib to plot this. So I can write sns dot set, and here I'll write plt dot figure, and inside this I can give a figure size of, let's say fixed size is 6,6, and let's say I want to plot a dist plot. This plot we already discussed in the video of Seaborn. So if you are still confused in the concept, you can refer to that video and write dist plot, and here I can write df of, and I want to use age column, so df of age, and I can give the title to this plot. Title will be age distribution, and finally plt dot show method. So we'll finally have this kind of plot for our age. So we can interpret like the density of the people in the 20s is very high. So this gives us the idea about the age distribution. Now let's make a bar graph for sex distribution. So we want to understand the data about the information about males and females present in the data. So we can understand that with the help of a bar chart. So I can write plt dot figure, and I'll give fixed size that will be 6,6, and I will make something sns dot count plot. So I want the count for, let's say, x is equals to sex, and data that I want to use is of df, and plt dot title is sex distribution, and I'll write plt dot show. So this is the sex distribution that we have inside our data set. Almost identical number of male and female. I can also check this with the help of value counts function. So df sex dot value underscore counts. So we have 676 males and 662 females. Let's plot the BMI with the dist plot. So I can write sns dot dist plot, and directly I want df of BMI, and I can write plt dot show to plot this. So this is the distribution plot for BMI. And next thing, so the normal BMI range can be like around 18.5 to kind of 25ish, and so these are some of the basic visualizations that we did. Now let's also get an idea about the distribution about region. So how many people are from southwest, northwest, or maybe northeast or southeast region. So I can write something like df of let's say region, and I want value counts about each of the category present over here. So this is the number of people that we have from different region. Now let's perform some data encoding. So we, as already discussed, this data set contains some categorical features, so we have to encode them before giving them as an input to the ML model. So first I'll encode the sex column. So I can write something like df dot replace, and then I can write so sex, and I have again male will be replaced with 0 and female will be replaced by 1, and then I have to make this change. So I can give in place is equal to true. And finally, next thing I want to encode is the smoker column. So again I can write something like df dot replace, and here I can give smoker. For yes I have 0, and for no I have 1, and again this will be in place equal to true. So I'll copy this, and finally I'll encode the region column. So because region has 4 different categories, so I can give 0 for southwest, 0 for southeast, 1 for southwest, 2 for northeast, and 3 for northwest. So I can write df dot replace and then finally in region for southeast I can give 0, for south west I can give 1, for let's say northeast I can give 2, and finally for northwest I can give 3. Again this is in place is equal to true. Now split the dependent and independent features. So for my x I have df dot drop and columns will be equal to charges and axis is 1. Y will be df of charges. So this will be my x. We have already done the data encoding for children, smoker and region column, and this will be my y, the values for insurance. Now let's use the train test split. So I'll make x train, x test, y train, y test. This will be train test split x y test size, let's keep it 20%. We can check x train dot shape and x test dot shape. So we have 80% data for training and 20% data for testing. Now let's train the model. We'll use simple linear regression model to predict it. So regressor will be the model instance reg linear regression and reg dot fit. This will be x train and y train. Then let's check the prediction on the training data. So I'll write training data prediction. This will be reg dot predict and I'll give x train over here. Now let's calculate the r square value for our training data. So r2 train, this will be equal to matrix dot r2 underscore score, and this will be y train and training data prediction. So R2 train, we are getting around 75% R2 0.75 the R2 score for training. Now let's check the test data prediction. So I'll write test data prediction reg dot predict and this will be x test. So I can calculate the R2 score for test. So R2 score will be y test and test data prediction. Okay, I have to write matrix dot R2 score. So we are getting around 74% 0.73 0.74 R2 score. Now let's make a predictive system. So I'll make the sample input data first, sample input data, and this will be, I'll keep in mind the values and the type of data that we have in the data set. So let's 30 um, 1 22.7 and 22.7. Then we have 0 1 and 0. Now let's change this input data type to a numpy array. So input data as numpy array. This will be np dot as array, and I'll give sample input data. Now let's reshape this array. So input data reshaped, this will be, I'll copy this, I'll paste it and call the reshape function and 1 comma -1. Then finally I want the prediction. This will be reg dot predict, and here I'll give this reshaped data, and I can print the insurance cost is prediction. So the insurance cost is 2223.03. So this is the predicted cost for these features. So here 30 will be considered as the age, and because we are giving 1, so it will be considered as female. 22.7 will be considered as the BMI, and then 0 will be considered for 0 number of children, smoker, and it's a smoker because we are having 1, and finally 0 for the southeast region. So this was the complete medical insurance cost prediction project that we did. I hope you are clear with this. Now let's move to the next video. Thank you.